Hello there, this is Talent and Gospel, and welcome to today's stream. Today, I want to show you how to build a token-driven application using the SPL library of Solana that we have been working on. You understand? So we're going to put all those things together and paste together a full app. We're going to also integrate the wallet authentication. You see a whole lot of instruments that makes for a good Dapp. So we're building everything together. Currently, this particular project, I've already hosted it online. I've tested it, and it's all there for you to visit. I'm going to drop a link in the description section as well, so that you can observe it for yourself and buy some tokens, maybe from me. So that's what we're doing on this particular stream. Like it's awesome. It's going to be awesome. So please, even though I don't say it, please just know that we would like you to hit that like and subscribe button. It's part of what we're doing here, the sacrifice that we're putting in here to publish this content for you for free. The best that you can do, the least you can do, is to hit that like and subscribe button so that this particular video can be seen, these works can be seen more in our space, in this blockchain space and all of that. You can see that we are actually shipping out a whole lot of premium useful content in the blockchain space. Many other channels, they are not doing so. So I would really appreciate it that you push this work for us and share it, refer people if you can, and do the good work. So that is what it is today. I don't have much to tell you except let's jump into the tutorial and start working on this project. So this is the project that we'll be working on today. It does look simple, in the outward of it, but it's a lot, especially if you coming straight up from Solidity. So there's gonna be some few changes here and there. Okay, so you just get it together. So I'm going to be taking you straight forward, and we'll do a demonstration so that you can see what we're talking about here, and then the rest of the stuff. Okay, so let me just refresh this. So when you refresh, you can see we added that very nice looking loading progress bar, whatever they call it. Okay, UI loader. Okay, a UI loading animation. So right here is a button, okay, which we can click, and you can see that fancy looking interface. See, please, you should have Phantom wallet installed. So that is one of the things that you're going to need. You need it installed. I think I'm just going to help you, just show you an example of how to load up some of your wallets, your Phantom wallet with some tokens, and all of that, so that you can use for this tutorial. Okay, so I'm going to connect a Phantom wallet here. Before I connect that, but let me do that first. So I am connecting to dev3, but I feel like I could connect to another one. Let me connect to dev1. Let's say dev. Let's say dev4. So I'm connecting to dev4, and if I've purchased some tokens here, I previously purchased up to 6 tokens there, and it's going to just retrieve that information, including the transactions that I've made as well. So right now, if I want to purchase, let's say I want to purchase, we are selling a token of DMA for, that is Dapp Mentors Academy. If you don't know, we're selling one token for 0.02 Solana token. So that is what you're getting for each DMA token. So I'm going to select, I want to get like 4 DMA tokens. You can see how if you don't actually have any value, like you can put 0, it will disable this this button. You can see how the fancy looking icon of Phantom, and then the wallet. This thing is all made possible using Solana wallet adapter, which I'm going to show you as well in the course of this tutorial. All of these things are just available freely on GitHub. I'll also drop the link to the GitHub repository so that you can refer back to it. So if I just say, let me buy 3 again, let me show you this. Confirm. You can see that this went to 18, but it's saying error here. So probably one of those issues, but we're going to figure it out. But to have it all, to put it in perspective, this literally is working. You can see that all of these things are actually being reflected properly. So those are the things that you need to know. Yesterday when I tested everything, it works just fantastic. If you actually click on any one of these transactions, it will take you to exactly where that transaction took place. You can see the kinds of transactions that happened under the hood. Okay, so you see all the expenses that was charged. You can see how the token balances were transferred. This had now 18 DMA, but 3 was added to it, and you can see 3 was subtracted from this. So this is the token account. This is the one that is selling, and this is the one that is buying. You understand? So those are all the transactions that is taking place here. You also, if you click on this address itself, you can also see information about this address. Okay, so you have this address having 18 Solana token. These are all the transactions that happened so far on this particular address. So there you go. So let's jump into the tutorial. So to jump into this project, the first thing we need to do is to have all those things that we normally do have installed, which include it will include Phantom. Please, if you don't have Phantom, you need it for this particular. So you go to their website, or you can check it in this Chrome store. When you go to Chrome store, you can install it from there. So you can just download for Brave here, and it will be installed. Right now I already have it, so I don't need to download it again. So here is my Phantom wallet. Very important. And I have some free ethers. You can also list all the token, all the token account that you all the tokens that you've minted as well, which is really cool. Like one of the cool things, like you can see your balance here, of each one of the tokens that you have gotten. So you can see I have about this number of DMA tokens, and you can send this token as well. You can send it to whomever you want to send it to. Let's go to the next thing. The next thing you need, of course, you need Node.js installed. Please, Node.js is very important here. You need Git CLI, you understand? GitHub CLI for you to operate. So I need to go to GitHub, Git bash, sorry, not GitHub, Git bash. Okay, you need that Git bash available there for you to, you need to download it for your specific operating system, if you're Mac, Windows, or Linux. So you need to have that installed. What else do you need? So after you have all these things installed, the next step is to, let me drag this into my screen, make sure that I put it here. So the next thing you want is this particular project. I want to install this project. So this is the piece of work that I've just finished working on this. I've documented this very well so that it will be easy for you to utilize. Okay, so you just, every of those instructions has been set up already. Okay, so I'm going to run you through this, and we're just going to get it together. So what do you need to do? You need to do this first. Copy this, open your CLI, your command prompt. I'm going to come to terminal. All right, so in terminal here, you need to go to this is site. This is where I have all my project work available. So I'm going to do git. If you do git clone, if you do git version, if you have it installed on your computer, it's going to be available there, like you can see. But if you don't have it, it's not going to be available there. So I'm going to do git clone, and you put this. You can give it an alias. An alias could be whatever name that you want to give it. So for this project, I want to call it YT, because I have other alternative of it. Tokenizer. Okay, tokenizer. All right. So we're gonna clone this project from our repository online. So we're getting it all together. So there we have it. We can open it with code, VS Code, say code YT tokenizer. So you open it on VS Code. That's taking it some time. Okay, VS Code is launched, and the project is right here for us to view. Okay, so this is the main branch of this project, meaning this is the finished work of this project. But we're not dealing with finished work here. Okay, so we're dealing with, want to start from the interface angle of it. So I'm just going to switch to this particular branch here called no Redux. Okay, so no Redux right here. So I'm going to switch to that branch. We have no Redux. Okay, so I'm going to make sure that my face is not covering anything here. Hopefully, I've been still working on this together. So now this is a project here which we can easily launch. Can launch it. If you're using yarn, that's cool. You can do yarn dev. But if you want to use npm, you can also use npm run dev. Anyone works in this case. Sorry. I haven't installed this project yet, so it can't start. I need to install all these packages, so that's why it's having all these issues. Okay, so I'm going to run that now. See, this package has a lot of things, and I really don't know, this is not useful in this project, right? So I'm going to remove anything that is not useful in this project. I think the rest are just okay. I don't need moment. I didn't use it in this project either. So I'm just doing this to reduce. I didn't use swiper either, so didn't use react moment. Alright, so the rest of them, let them just stay like that. Okay, so I'm going to save this now. So we want to install this project. Let's run yarn install. Okay, you can also use npm install as well to get it done. So I'm going to run that, and you can see it's fast. It's fast because I had previously done all this work, so it's basically just pulling from my cache. Okay, but yours could take some time, and there's no issues about that. So that's what you should know. Okay, the installation is done. Fantastic. Let's run yarn dev so that we can see this on the browser. Okay, started. Come to the browser now. Here we can go to localhost 300. Okay, so here we have it. This is the project. These are just dummy stuff. There is nothing useful here. They are just dummy things. Okay, if I refresh it, it's gonna happen the same way. You can see nothing happens when I click on connect. All these things are just dummy stuff. All HTML and Tailwind design. There is nothing. By the way, this is also very responsive, in case you want to look at it from a responsive mode. There you go. So there you have it. So now, hope all of us are in the same space, and let me just introduce you to a couple of things here. Let me do this. Sorry. So we have just one page, which you already know, this index page. Okay, and this index page has 3 or 4 components: this header, buy token, balance component, and mint history. Okay, so right now I just have a dummy use effect that just execute this function called fetch data. What this fetch data does is very simple. It gets a dummy data. This dummy data, I got it. This is the dummy data here. It's just a JSON string that contains some dummy information here. Okay, so these are just some dummy information and nothing more about. That is how all these links that you're seeing, they are just dummy data. So we're grabbing it there, and we already have this array that has main history, that has all the information about the main history. And you see this set balance, which is just basically the balance is just 0 because I set it to be default here, and just setting it there and saying loading is false. So basically that is it. So let's go through each one of these components. So this first component, I have it in this component folder here, or this component here. So this component, what it does is connect wallet. Is just a header component that has, a p tag with this and a button that is just designed in. There is no functionality here. Okay, the same thing with this buy token. This buy token is a form, you understand. It receives an input amount. Okay, we also have this handle submit function, which we are intending to use it to execute the function, okay, when we are working on this. All right, so we use it to execute the function when we are buying some tokens. Okay, and we have this particular form here, which is just this form executes this function, and it receives only one input. This input takes the value amount here. The minimum should be 1. I don't even know why I said it like that. So the minimum should be 1, and the maximum, this is the price that we use in purchasing one token. So you can set it here by default, or we will do this later, but I'm just giving you, this is just regular stuff that this will be used to set dynamically the amount when you're changing it and so on. And this button submits that particular form. So those are just the information that you need to know. So for this particular token, next thing also, we need this balance here. This balance component, it receives a balance and simply just displays it, which is here. All right, so that is how you have this is a balance component. You can see each one is a component. The header is a component, this input and this main token is a component, this balance is another component, and we lastly have this history component here. So this just displays the balance that a certain account does have. And lastly, we have this mint history. This mint history basically receive a historical record of transactions that happened for each wallet in particular. So we can decide to put it on the main token wallet address, or the particular buyer of the token, or the seller of the token. I think the seller of the token will be much more appropriate for this particular stuff. So basically just a loop function, a map that just loop through an li tag and supply information such as the link to that user's address. So this is the one that purchased this particular token, and this is just a format, something we use in formatting that a function we use in formatting that wallet address, so that it will have that 3 dotted and 3 4 dotted part, just truncates the function. So this is the amount, and this is a link to see the transaction itself. So those are just it, those simple stuff. So that is all there is that we've done so far in this project. We've not done anything other than that. So from now henceforth, we're going to jump into the next part of this tutorial, which is where we have you set up your we'll work on this part first. Work on the connection, ability to connect wallet. Okay, when we'll connect wallet, we can click on this and it connects the wallet, and then we can proceed by loading up some Solana tokens on it so that we can start using it. All right, so I'll see you in the next part of this video. So coming to integrate this particular wallet, whether it is Phantom or whatever compatible wallet that you want to use, we have a particular setup process that we use for that. First of all, we've already installed that. So I'm going to come here. Let's come to this project here. Come to component. I want you to create another component, a new component, call it, sorry. So it's going to be called app wallet provider.tsx. Okay, so this app wallet provider.tsx is going to help us load up that entire, it's going to serve as a provider for connecting any wallet that we want to connect on this Solana space. Okay, so there are many wallets, so we want to use this particular one for this purpose. The process is quite simple, and I think, what I will do is I'm not going to code up all this part because it's just redundant. Basically, go to that. You can just do a minor Googling, and you'll be able to see how to install, how to get it together. But you don't need to do that anymore. That's why you have me here. So you have this use client. You paste this code here. So this code uses React and use memo, right? And use memo is helpful to remember something, all right? So that you will not have to be calling that in over and over again. So it helps to recall stuff. And you have this connect provider, this wallet provider. You're getting all this information from this Solana /wallet adapter/React. So it's a wallet adapter for React package. And you also have this wallet adapter network. All this information are important. This wallet adapter UI, and this is basically Solana's Web3 SDK, which you can connect to cluster. And you have some wallet adapter that you want to use, which you can connect. You can see Solflare wallet adapter, and I think I could have connected more than this. You can connect way more here. So this is it, and this is the CSS that is required, that comes with this wallet adapter as well. I think, let's say if you can have Phantom wallet adapter, yeah. So Phantom is here as well, so you can include that. You can see the network, this app wallet provider, children, and so on. So if someone has a Solflare wallet, they can actually use it in place of this Phantom as well. So we have the network that we're selecting to be DevNet. So network is DevNet that we're selecting. You can also decide to make this dynamic, but this is DevNet. This is pointing to DevNet. We use that to form the endpoints, and memorize it. Okay, so now I'm going to add this here. So we have Phantom right there. And these are the wallets that we're using, we're memorizing, and under this network, in case that network changes as well. So that network is a parameter here. So then this is the component that is responsible for this. So you connect provider components and endpoints, you add the endpoint, the wallet provider, you add the wallets, and you put this auto connect feature so that when you refresh your page, it automatically just connects. And then this is the wallet model, which is wrapped around your entire application. So this children is where we're going to put in the entire components that this particular project comes with. So I'm just going to save this. After you save this, you need to come to this app component, sorry. So in this app component, you can then call on this component, call it app wallet provider. Okay, and paste this inside. So this is it, and yep, basically this is it. You just wrap it around the entire application and you're good to go there. You save here. So currently it doesn't look like there is any much of a difference, until we start utilizing this, connecting this wallet. So everything looks just about the same. This is a little bit slow, so it's compiling. So as of this point, we need to then head to this header component. Okay. In this header component, I'm going to, I think this is fully loaded now. So it's fully loaded. So nothing is working so far. So what I'm going to do now is let's code up that functionality that will help us to connect our wallet. So the first thing I want is, if a use state called is mounted. So is mounted, I want to set it to, also want a function called is set is mounted. Okay, so this is going to be use state. Okay, so by default is false. Okay, so is mounted is false. And then I want to set up a use effect. This use effect, I'm going to import it here. This use effect, whenever the page is fully loaded, we want it to set this is mounted to be true. Why we did this? Because we don't want, this is NextJs, remember. We don't want NextJs to just render this component before some certain information, some certain functionalities of this wallet provider is not available. So we want to make sure that they are available at the same time as it start producing some stupid errors on the interface. Okay, so this remains the same. Okay, now what I want to do is now utilize this wallet button. So there's something called wallet multi button. Wallet multi button, we're getting it from the React UI. So if I grab this here, see it automatically imports it as well. So yeah, so this wallet button, and we'll just need it to be one tag. So we don't need this anymore because they look just about the same. Okay, I'm just going to add a little bit of a color to it. But before we do that, I'm going to show you what it is. So right now, before this component, before this component renders, we want this to be set to true. So that's why I want to wrap it around. Say is mounted. If it is mounted, then it should render it. Otherwise, it shouldn't. So let's save this and check it out on the console. So look at it. That is called select wallet. You get that. So we need to, the color is not matching our design. So let's improve that color. If you want to improve that color, you can simply just give it this style, background color to be this, our orange style, and the color itself to be white. When you save that, you come back, you can see that we have it here. So now when I click on this, you can see that I have various options for me here to select. So I can then select this phantom here, and you can see that it's connected, right? Which is cool. So you can also click this to disconnect it and so on. You can copy wallet address and so on. So this is cool on my own end, but on your own end, it may look like you don't have this, you don't have a wallet to connect. So one thing that I normally do, remember that project where we had, remember the project that we earlier worked on. Let's see if I can pull that off. So if you go back to that project, or I'm just going to look for it on my repository. So go to my GitHub page. So I'm going to say this. So we're generating keep here. All right, so we can use this to generate keep here from Solana. So I'm going to copy this particular file so that let's generate a key pair for you. Okay, so I'm going to come here. Momentarily, we're going to create a script at the bottom of this page. Call it key pair.ts. Okay, so I'm going to paste this. What I'm going to do is to just, so I'm going to run this particular script now. So to run this script, I'll open another interface. So I'm going to say ESRun. So that's why we have ESRun is a package here. If you come here, see ESRun, look at it here. So it will help us to run this Typescript package. So you want to say npx ESRun, and you want to say key pair.ts. When you execute this, it should generate a new so it should generate a key pair for you, and this is the secret basically. So this is what we want to copy, is the secret that gives birth to the public. So I will copy this secret code, then I think we can format this properly. You can say secret here, secret. Okay, so I'm going to run that again. Okay, so this is the secret key right here. So I'm going to copy this. So when you copy this right here, you want to make sure that, it's well formatted. I want to copy this secret key, okay? And then you can come to your Phantom wallet. Okay, you can make sure you switch to this test mode, and how you can do that, you can just come to these settings. I think you can actually test mode, or you can come to developer settings. You can see this test mode right here. So you switch to test mode so that your account can be on test mode. And for Solana, you make sure it's on this DevNet. All right, very important that you do so. So when you do that, you have this test mode. Now you can add a new wallet address. You don't create new one. You import from, not from secret freeze, but from private key. So you click on this and I paste this here. You see that the format is incorrect and it doesn't quite translate to what we are hoping for. So it doesn't work. All right. So for you to go about this, we're going to use this package that I also installed. It's called BS58. So we need to use that to translate this secret key into a format that you can easily use. This is the easiest way, one of the easiest way, okay, to get this whole this whole thing working. So I need to import this. Say import BS58 from, say, BS58. So once I import that, okay, instead of, I could then, have these, I could also do something else. I need to decode that private key first. So using that BS58, so I can say const this private key, key, say base 58. Okay, this private key that is in base 58 format, we can do this BS58. There's a function called encode. Okay, so we need to encode it to that format. So what we're encoding is this key pair dot the secret key. So with this, we can then have this logged out. So we can call this the private key is. Okay, so let's have that logged in. So when I execute this function again, it's going to print out this format. Now you can see this right here is the equivalent of this. Okay, so I'm just getting it in a in a format that will really apply in this Phantom wallet. So when I click on this Phantom wallet, I need to add a 6th wallet now. I import that private key, paste this here. You can see how it just accepts it, and you can see the wallet address straightforward. I could call this dev6. Okay, so I import that. You can see that it's imported, right? So when I copy this private key, I can then send it from any one of my wallet that has a lot of tokens. So let's say this one has about 16. So I can send to that wallet. I could use this Solana send to, I need to select this dev6 here. So I want to send to dev6 6 tokens, or let's just give 5 tokens. So we click on next. You confirm that it's trying to check network fee. So confirm that. Okay, so that has been confirmed. So we'll close this. And when you come to dev6, you see that 5 tokens have been sent to this account. So I can then use connect to this account. You get that. So dev6 is connected. So basically, this is what you need to do to set up this whole header component. We're done with this header component now. The next thing we need to do is we need to launch our token. All right. So we need to launch our token. I've not shown you that part. We will write script for launching each one of those tokens. So I'll see you in the next part of this video. Now that we have this all taken care of, I can remove it now. And let me close all this and clear this. Come here. So one of the things we want to do is want to create a script folder. I think I have all the script. I'm going to delete it so that we can start from scratch. Okay, so I will say this new folder, call it scripts. Okay, inside the script here, we're going to have series of scripts that we want to run. All right, so this script part is very important because this is how you launch your token, set up all the things that you want to set it up for. So I'm going to create a new file, call it, I'll give number 1, call it deploy, deploy dot ts Typescript. For this deploy.ts, I'm going to need a couple of things. See, what we're doing here, we've already done it before. I've already shown you how we launch, we create, what's it called? I've already shown you how we create tokens and all of that. So for this tutorial, I'm not going to be doing a whole lot of that. What I would just call is create a new file. I'll call it, reuse.ts. This reuse.ts is going to have some shared functionalities among this script that I want to write now. So what does it have? For example, we want a function called checkOwner. Okay, this function checkOwner is, we want to make sure that before you deploy a script, you have a wallet address, a key pair that you have already, you've already created. I don't know if you understand this. A key pair that you've already created. One of the things that I did not do was, I think we should do that quickly, if I can retrieve it back. Man, I hope Phantom has a way of retrieving stuff. I mean, with if it was MetaMask right now, I think I can. Okay, so get show private key. So I can do that as well. Okay, let me do that. So this is a private key. So I'm going to copy this private key. And let's see if we can decode this private key, So if we come to this key pair, I want to say const decoded private key. Okay, so I would say is equal to this base, this PS5, and say decode a string. Okay, so and when it's decoded, this is the private key. I just want to log out this decoded private key. So let's do this because I will need that to be used. I will need that to set up my environment variable. It's very important that I do so. So let's run this again. Run that command. Okay, so this is the private key. So I'm going to copy this for this particular string. I mean, if you want to confirm whether it's true, is by running it again and compare what you get in the both. Okay, you see that they are both the same. They are both the same. You can see that as well here. So I'm going to copy this whole private key here. Now I can remove this thing. So when I copied it, I'll come here. I want to create an environment variable .env file, create one in the root of this project. So this environment variable is going to have this. No, I'm going to put it this way. So okay, so we have a simple string here, but we need to set it up on a variable. So I'm going to call this here NextJs keep here. Okay, so here we have it. This is a keep here token here. So this is very important that I needed. That's why I had to pause this. So I had to come here to get it together. So this is how we know the token owner. All right. So this function is going to be useful for me to know whether that keep here that I just added in my environment variable is present or not. Because if it's not present, then we cannot run this operation. So how do I get it? I need to say export const this token owner is equal to, I need to call this process dot env dot, I paste in this private key. Okay, so now you can't just call that process dot env without you having this package here dot env. Okay, so because of this dot env, that's why we need to bring it here so that dot env will be, so that it will be aware of this environment variable that we're picking up from our .env file. So after you have this thing, okay, the next thing you want is to decode that. You want to convert it to a Solana key pair. Okay, and how you do that is very simple. So you need to make sure that this particular token owner is possibly undefined. To fix that, you need to make sure that it has this or symbol. So it can be either, if it is undefined, you need to supply an empty string. Okay, so and this basically makes sure that you don't have an empty string. Okay, so now we have this gets you the owner array, which is an unsigned integer. Just format it in that way. You know that what I added there, say .env. You do know that if I say code.env, what we have here is just a string. It's not formatted in the way that you needed it to be formatted. So you see this token.owner.split. So I'm basically converting that string into an unsigned integer 8 array, okay, 8-bit array. All right. So after I've done that, I can then convert this particular those unsigned integer 8-bit array into what we call a key pair, and you need to import this key pair from this Solana Web3. So this key pair, and then it's a secret. So you are converting a secret into a key pair. So it's very important because we're going to be using all these things. One last thing we want to get together is we need a function. Okay, this function is called, let me import this public key. It's going to return a public key. So this function, what it does is to get the token mint address, the address of I could just call it get address, get token address. Okay, to get the token address from the location where we set it. So, and the location where we want to be creating this token, because remember in my Solidity trainings, anytime that I deploy a wallet address, it's being stored in a special, location. So for this particular one, the location I want to store it is a place called services. Okay, services, a folder called services, and then I want to name it token mint dot JSON. Okay, in a JSON format. So that is one thing. But you need to make sure that you've imported this path, because it needs paths to navigate in the direction. So after you've done this, but you need to check if that path does exist, because if it doesn't exist, then token mint file not found. So what I'm going to do is I'm just going to come here to this, say touch. Okay, so I can say in this root folder, say make directory, you can just create it, call it services. Okay, and after I've done that, I could then say touch this, and it's created those information for me. You can see here that this is a folder called services, and it has created this empty file called token mint. So with this in place, you need this FS module, but that FS module is not yet available. I have to import it, and you can import it from this particular place. Okay, so we're importing that, and this function is still showing red because we need to return a public key. So there we have it. So it makes sure that that file path exists. All right, so with that file path existing, we can read, this file from this file path. After we read it, you use this fs.readsync and the file path and the format that you want to read it. Okay, we want it in UTF-8, okay, format. So, and then once you grab it, you know that it's a JSON. So, but you want to pass it. When you pass a JSON, it becomes an object, right? So you want to say this token meant, you pass in that token string, which is the file that you just read, and then you turn it into an object. And then when it becomes an object, you can just return a public key, okay? But you need to term it new public key, okay? And you pass in that token mint. That's if an address. The token mint is going to have an address. Basically, that is what we mean by token mint address. So then this is what is going to return to whomever is calling this function. So these are some reusable things that we're going to need in this deployment script here. So now with that done, we're always going to be using it across multiple places that we'll be calling it. So the first thing you want to do is, before you even run this deployment script, you want to check, owner. Okay, you want to execute this. So this check owner will check if this private key does exist before it runs, because if it doesn't exist, then it's going to be producing error. So outside of that, you need to, create a connection. Okay, you need to create a connection to the DevNet cluster. All right, so you need to import this connection from Web3, Solana Web3, and also this cluster URL as well. You need to import that. Once you have that, that will be your connection. Then you need a function called create token. So basically, this is what we want to create, and it takes in the key pair of the owner of this particular token, the person that wants to create this mint token. It takes in their key pair. So all this thing I'm doing is all of this information that I'm giving you. I've already previously taught it in that early base tutorial. So you just go back to that playlist. You see all this information there, but I'm just structuring it in a way that will make sense for a web developer, someone that is pushing in code. You see, we're no longer doing the basic stuff. We're doing something that is well structured so that it will be easier for you to push up new tokens and easily make it some kind of automated. You understand? So now we have this key pair here. So what do you need to create a token? To create a token, like we've done before, if you refer back to that project that we did, you need to import this. You need to import this particular function called create token from Solana token, SDK. So this place here, this SPL SDK, you need to import this create token. And once you import it, you pass in this connection. You pass in the owner key, because if you look at this, there used to be a way. Okay, so if I hover here, you find out that the parameters that are needed are the connection, the payer. The payer is whom is paying for this transaction, and it has to be a key pair. All right. As you can see here, that the payer is a signer, so a signer requires a key pair. And the mint authority is whom will be in charge of regulating this token. Okay, so that is the mint authority. The freeze authority is not going to be needed, so you can pass null instead of a public key. The decimal places, so you need a decimal, which is basically 2. You understand? And the rest of the information are not really necessary for one to use, So that is what we just put here: the connection, the owner. This is the mint authority, which is the owner's public key, and the freeze authority is null, and then the decimal place is 2. Okay, so after we've done this will return, create a token mint, and return that URL for us. So we can just simply log out the transaction that took place there. Okay, say finished, created token mint, and then it passing the address for you. Now we need to write this particular address, the token address, to a file. So that's what we're doing this. You see, this address, we say JSON.stringify an object. I'm saying the address is equal to that token, string, the address of that token that we just clearly created. All right. And after we've done this, we can write it to a file. To write it to a file, you need this fs module. And you can import it by just copying this line of code, import it here. So this fs module, this write file, is a function there. You pass in the location where you want to write it to, the data that you want to write to, and the format, which is this UTF-8. And if there is any error, you should log it up. But if there is no error, you should just say the token has been deployed. All right. So this is all there is about this. But afterward, you want to execute this function using this main function. This is how I normally code my stuff. Okay, so I'm sure you have a way you can do it in a very simple, straightforward way without you requiring to go through this process. So I want to create a token now. To create a token, I pass in this await, because this is an asynchronous function. So I wait, and this create token, I need to pass in this owner, and I'll say owner. All right, I'm importing owner from this array here. So I'm importing owner there, and I don't even know why I made this an export. No, this one here, it's not necessary that it should be an export. So this owner, I've imported it from this place, so it's going to get me the owner's key pair. All right. So after I've done this, I then need to wait for about 1 second, because sometimes it takes a couple of time for these things to synchronize properly. Sorry, so I want to wait for like 1 second before I get, or like that, like 2 seconds before I pull that token that was just created, from the file location. So I'm going to call this. So I want to grab this token that we just created. So I'll say get token address. Okay. So it gets me the token address. I just, log it. I'll say finished deployment complete. Otherwise, I'll say that there's an error. So now all you need to do is to just execute this main function, and we have this deployment script up and ready. So why don't we test this deployment script and see what we're talking about, if everything is all good. So right now you can see there is no nothing here, right? So if we come back here and let's execute this function. Okay, so I'm going to say go to this script. Okay, and want to run that number one deployment script. Okay, and let's execute this script now. So it's running the deployment. So you can see that this script has been deployed, and this is the script address, and that is just it. When you open here, you can see that this transaction has been done. So if I come to this Solana Explorer for the DevNet, and I pass in my information here, if I pass in this, okay, I click on this here, you can see that this is the token program that has just been deployed. You can see the decimal there and all of those things. I could basically just break this a little bit and make it okay, so that you can see this properly. This is just for your own enjoyment. So so right here you can see this token mint, right? So this is a token we just import, we just deployed. All right, it doesn't have any information yet, but just very simple stuff like that. So we're going to do more of this. At the end of this, we're going to chain all of those scripts together so that we execute it once and all of them just get done. All right, so other than this, the next thing we want to do is to I did it this way so that it will be easier for you. Okay, that is why I did this. So the next procedure is to create an associate token account. Okay, an associate token account for this particular owner. All right, that is what we want to do now. So let's create that associate token account, and to do that, I had issues while creating this associate token account. So let me just remove all this. We don't need this, and we definitely don't need this function. I had some issues while creating this associate token account because the associate token account does have some, at least in the DevNet, I experienced some lag. Like if you try to execute it one time, it fails, so I have to make multiple attempts before it works, and when it works, then I can then proceed. I don't know why it behaved like that, but I had to find a different way of implementing it. So I'm going to come here, remove this. Okay, I'm not going to remove this. These are going to still remain, so because I'm going to need them. So let me import this. Okay, so now I want to create or want to get an associate account that already exists or create new one. All right. To do that, I want to make sure that I secure myself in case there are failures, because I told you that I have to make multiple attempts before I can create this particular associate token account. An associate token account is the combination of someone's wallet address plus the token's wallet address. That is what is used to form an associate token account for each particular token. So for each particular token, the associate token account is going to be different for that. So that is what you need to know. But we can use a while loop, all right, to make sure that this particular procedure is carried out more than just once. So we're going to do a try catch here. So we can say a try catch. So in this So in this try catch, the first step that I want to do is, I want to log out something. The first time is attempting to to create an associate account for the mint token. All right, so it's going to attempt the first time. So it's going to do that for this number of times that this max retries, which is 30. All right, so it's going to perform that. What we want to do is just grab the associate token account. Again, this is a function for you to do so. And if you're having confusion about what I'm writing here, I've already done this thing multiple times. In that series, you can refer back to it on how I created associate token account. Is very simple. So I'm going to just import this. This is part of the Solana, program library for token that helps you to create an associate token account for a specific token. So you need to pass in the connection. You can see here that you need to pass in the connection. The payer is the person that will be signing this transaction for gas fee and all of that. I need the mint token, which is the address of the token that you want to create an associate account for, and the owner of the account the owner of this account. You can set it here, and that is just what you need. So that's what we've specified here. So you can see the connection. This is the person paying for this transaction. This is the token mint address, and lastly, this is the public key of the person that you're trying to create an associate account for. And once this associate account is created, the next thing you want to do is to just log it out on the console and return that address so that this public key can resonate with it. So that is what we're doing here. After you've done this, if there is any error, you want to also log that error on the console. So you say if there is any error, you want to log the error saying error creating or fetching associate token account on attempt. So you see this, you increment the attempt so that you can run this again. So you can say, but you need to make a break statement in case it's over. If in case the attempt is greater than or equal to the max number of retries, you want to just say console.log max retries reached, throwing error. You get that whole thing. So then you throw this error. This error will break that console. You understand? I mean, this whole while loop is going to break it. So that's what you should know there. And after this, you want to also log off something like retrying, to give that the individual some context of what's going to happen next. So it's retrying. At the end, if there is any error, you can also log it out here by saying by throwing this error saying fail to get or create associate token account after maximum retries. All right, so it will break with this token as well in case it runs all the way. So this is just very important, and I use this to secure myself from running into bug while I'm executing a chain command. Just imagine I have about 5 commands that I want to run at the same time. So I need to put this so that if this function is misbehaving, it will not fail, okay? So that's why I added that there, so you should just know, all right? So like what we did with the deployment, the first step that you need to do, let's go back to that deploy function. So the first step that you need to do is you want to grab this token address. So I'm grabbing that. After I've grabbed this, then you want to create the associate token account. So call it ATA, which is for associate token account. And you say await, you say get or create, you invoke this function. Then you need to pass in this token mint. All right, so pass in this token mint. Okay, you know that, okay, you pass in this token mint. You also want to make this, you want to pass this as a key pair here. Because if you don't do that, it's just going to read from here. So it's key pair. Okay, so you also want to pass in the owner here. Okay, so that will create an associate token account for you And once it is created, you can just say, log it off that it has been completed, because that associated token account returns an address. All right. So this is what it is. And we can save this. Now we don't need this here. Okay, because it's been taken care of from this check owner, file. So if we come here and run this, so number 2, it is. So you execute this, you can see that it's attempting to create this associated token account. You can see that the first attempt it failed, it's still failing. You understand? So this is one of the reasons that I did put this attempt, because while working on this, you can see now on the 4th attempt it actually worked. Okay, and it's created. So this is very dicey. If I didn't do it like this and you're working on this project and you run this command and it fails again, it fails a 3rd time, then you start thinking that, oh, there is an error with this code or so. But this is just because of Solana. There is a problem with that. I think Solana need to look into it. So now that associated token account has been created, for this particular token. Now, on subsequent ones, if I should run this again, it won't need to create it from scratch anymore because it's been created. Let's run it again. It should just work, one time, retrieve it one time, and see that because it's already been created on chain and the blockchain is aware of it already. So that is it. We're not quite done yet, so we still need about a couple of more scripts to create. So I know I'm creating this script for you so that it will be easy for you to deploy, your stuff. So the next one I'm going to say is metadata. So remember, our token doesn't yet have a good metadata information. So it's just a blank token. You can see unknown token, doesn't have any useful information. All right, so we want to make that. We don't want that to be in that format. So what we need to do is to redefine how our metadata, we want to specify how we want our metadata to be. Okay, so again, I've already created these things are stuff that we've done already in that lesson series that we just previously completed. So what I'm doing simply here is to just utilize that information that we've learned previously, that I went through step by step to create, to utilize in this project launching now. So we need to set up, token metadata. So in setting up token metadata, I need to pass the token mint, that is the public key of the token mint and the owner of this token. All right, so I need those information. So there is this thing called token metadata program ID. There's a program ID that is responsible, okay, for authorizing metadata, okay, for branding tokens that is on the Solana ecosystem. So you always refer to, in fact, if you copy this, okay, and come here, paste it here, you figure out this is the token metadata program ID. This is responsible for allowing new tokens to have information. So anytime you want to create a token metadata, you have to always consult this, at least this version, before you proceed forward. So if you come back here, that is why we are referring to this metadata program ID. We need that. And then you need some kind of a metadata information, which is in object format. So this is here we tweak whatever we want to tweak. So for example, I want to, what should we name this token project? So we want to call it tokenizer, tokenizer coin. And then we can call this TKC. All right, so this is tokenizer coin. The rest of this can remain the same, but you know how you can tweak this information. I will charge you to, you can study this better and tweak that information to fall, into what you want it. Okay, so you can even change the image of that token to reflect to what you want. But for this tutorial, we don't want to go that much, into branding the token.
So we just want the basic stuff. So now this is what we call metadata PDA, and B bomb. So what happened is that we're calling this public key and we're finding the program, address to synchronize that metadata information on it. So you need to use buffer and merge this information. So in an array, you have buffer from, you're converting this keyword metadata to a buffer format. You're also converting this token program ID to a buffer format, and then the token mint, the minting address of that, this token, the public key, you want to also convert it to buffer. So this is an array of buffer also, and then the program ID. So this is what you use, to synchronize, right, with that. So after this is done, you want to say that, okay, we've created this token metadata. So this is a transaction, and it just created that token metadata. Okay, but it's not done. We're not done with it yet. In fact, we don't need to, it's not even executed yet. It needs to be executed. So, but this just prepares it in a way that we can, add it to a transaction. So once we get that, we can grab the first member of that array, which is, that is going to return, this array here, this PDA. This is basically the PDA, metadata PDA that we just specified. So we're grabbing that first member of this. This returns an array of items. Okay, so this is the metadata PDA that we're returning, and we want to grab that first member of array. And not just that, we want to create a transaction object. So we want to say transaction object. I'll call it a new transaction. Okay, so I could do this. So new transaction, I need to import this from, Web3, Solana Web3, right here. So now that we got that transaction created, we can create the instructions. So this is how we put this thing on the chain. This step does not put it on the chain. It just prepares it in a way that we can include it in the instruction that we're about to write below the, the metadata creation instruction. So we call this function, say const, create metadata account instruction, and then you pass in this create metadata, this, we need to literally just add it ourselves, and it comes from this function, this library called, and let me show you the library. I'm gonna come back here. It's that library. Open this. So look at this library called Metaplex. Okay, foundation, and so this is the package that we use in creating a metadata, instruction transaction. All right. So I'm going to call this, and we can import it. It's not auto importing, so I have to literally import it from that location by typing it myself. So I'm going to do this. So this is it. So I got it here now. So at this point, you add an object. The first object that we're adding, describe, that is this part describe the instruction, including who is paying for this and what is the details about the instruction, about the metadata. So, for example, it gives you information about the metadata, the mint, or the token that you're trying to put is the mint authority, the payer. So this is the payer. Okay, you can specify that it's public key, and the update authority in case you want to update this particular metadata. It's also the particular person publishing this token. So you see why that we needed to specify this in our next pair. So we needed to put this. This is the only variable that we'll put in our environment file. Okay, so with that in place, you also need a second object. This second object, why this specify the information about the transaction, who is to pay and all of that. This specify the information about the metadata. So it literally just gives you the metadata information. You get it? So that is just the difference between those two places. All right. So after you've gotten this, you can then add it as a transaction. You can call this transaction.add. So transaction.add, you add this, and you then send and confirm that transaction and log it out on the console. So I'm going to do this. So you need to make sure that you import this from Web3. So you send the transaction. This is a signature. So I could just call it signature. So this is a transaction. You say send and confirm transaction. You pass in the connection, the transaction that you're sending, and who is paying for this transaction, which is this owner keep here. So you put it and you just execute it and it is finished. So after it is done, you just call it here. You say await set up metadata. So this process to set up metadata, you pass in the token mint that you have here, and also the owner. Okay, so after you have that, you can simply log something on the console saying that you have successfully, set up the metadata. So you save this. Now we can test it out on the console. This is a lot of process, but we can set it up on the console. Let's clear this, and this time around we're doing scripts /0, that is 3. So we're setting this metadata, but please take note, before we even executed, let's come back to this place. You see that this token metadata doesn't have any branding, no information yet. So if I come here and execute this function, you see it goes, creates this metadata very successfully. This is the transaction information. And if you refresh this place now, you can see that it now have that, we have this tokenizer coiner. You can see that branding and, have that information about it. So it's not cooler, you understand? So this is how the instruction for doing this. You see, why I'm taking you through all these steps is because when I change this command and I want to execute it one time, I will not need to do this one after the other anymore. Okay, so now we have it there. So on the next part of this project, then we need to create, we need to mint this. I have someone in the comment section ask me questions about, not making this particular mint fixed, like it didn't have a max supply, from the series, the one I showed you was unlimited, so people can just mint as much as possible, which in the real world, that would be very deflationary, to make the token worthless and valueless if it doesn't have max supply. So part of the thing I want to do in this one is to make sure that we solve that problem by adding a max supply so that you can't go beyond that and people can just trade from that. So let's do that. To do that, I'm going to duplicate this ATA, copy, paste, and I'll call this ATA, this one, for mint. So what we're doing, we want to mint a certain amount of tokens. We want to mint a certain amount of tokens into the owner's wallet so that people can then buy from the owner, and then that will require an authentication so that you pay for the token before you get it. You get that? So I'm going to come here. I'll remove this. We don't need that at all, and we don't need this. So this information here. So now let's proceed. So it's a small and simple function. Let me just do it this way. So it's very small, simple function. It's called mint tokens. It takes in the token. It takes in the token information. That is token address, and the owner. You understand? The owner of this token. Okay, so it takes in those two information. So now you want to mint a certain amount of token to that owner. So I'll come here and say mint. I could do this thing instead of do something like mat dot power. I'll do 10 raised to the power of 2, which is the same thing as what I just wrote here. So let's go back to this. So the first thing you want to do is, this should be a keep here. Okay, so it's a keep here, and you pass in the connection. You want to import this from Solana program, token program, and you are passing this very well. And this one here, this is the ATA address. Okay, so this should be the associate token account for the associate token account for where you want to send this. So this is not keep here, this is public key. So let me take you through this again. So you need the connection, you need the payer which is the key pair, you need the mint, token mint, you need the destination. The destination is the ATA, the associate token account that is we're going to be minting this token to, because tokens are minted to associate token account. And the authority, the mint authority, is the owner's public key. And lastly, the amount of tokens that you want to send. So for this tutorial, we just want to send 1,000 tokens to the owner of this token account. So that is just what we're doing here. So after we've done this, then you can perform these two operations. The first step is to get the token. So the second step is to get the token associate account, so for this one, we're going to have to modify this function a little bit. So instead of it being, we can just say export here. So we need to export that function so that we can have access to it here. So we can say ATA is equal to await. So remember, we can import it from this ATA. Let's go back to here. So this returns the associate token account private key. So this is, let's just use a different way of doing this. We don't need to import this, so we can create this ourselves here. So we can just create this, which is for you to mint a token, you definitely need to grab this token associate account. So we just need to make sure that we don't even need to write all that. We can directly add it to this place here. Okay, so this is token associate account, and we don't need to add that here anymore either. So we can do this dot address. Okay, so this is it, and then at this point we can pass in this token mint here, and also pass in the owner. And sorry, we don't even need this function. We're not working on this one, we're working with this function here. So we need to change that. So this is what we have now. So this returns, we just want to mint the token straightforward. We don't even need to set it up like this. So once you create that, then you want to log off this on the console. Please take note that why we're doing this one and we're not relying on that ATA, because that first ATA will need to be executed first to ensure that that token is minted correctly. I mean, that ATA is created correctly and is on the blockchain, because if it's not on the blockchain, it's going to be failing. So with that aspect secured, when we run this, it's not going to produce any error again. We don't need multiple retries because it's just going to pull it from the blockchain. Now that is one of the things we need to know. So if we save this, and let's execute this now to test out our hypothesis. So we say, call this mint, and this should be number 4. So we'll run that mint, and let's see how it goes. So you can see that, token has been minted successfully. Unfortunately, it didn't just print out the transaction, okay, but we've minted this token successfully. That's just what you should know. But we need to, this is supposed to return a signature. So we can say const signature is equal to this, and we can log that signature off, like we've always done. Copy this. So minted tokens successfully. Or token mint complete. Okay, so let's mint another. Currently, you can see the supply of this is 0, but once I refresh this, the supply is going to get to 1,000. I mean, right? So, but I want to mint another. I want to mint another 1,000 token. Okay, so that means when I execute this again, it's going to mint another 1,000 tokens to that specific wallet. And you can see the transaction address. So with this, if I come here and I put this, I'm able to literally check the transaction and see how many. See that this is confirmed and it's finalized. You can see the person that benefited from this. Okay, so this associate account is the one that had received this 1,000 tokens. So that is cool. All right, so we have confirmed that is working now. So one last step on this deployment, sequence is, let's create the last one. And the last one is basically to disable, so that we cannot continue minting and minting. We want to make sure that that supply, that total supply that we have minted, that will be the only token that is in circulation. Okay, we don't want to have more than too many tokens in circulation, because that will affect the value of our token. So that's why we're doing this. So I'm going to come here. Now I will need to remove this function altogether because it's not needed. By the way, I needed to. Okay, everything is all good here. So we're going to create another function, simply call it disable mint authority. Disable mint authority. Okay, so now these things that I'm doing is very important for people to trust your token project, because if it's not disabled, that means you can always mint more tokens and then be selling it to people at, it's crappy. It's not worth anything that way. So you need to disable the mint token. So it's called, there's a function called, I'm going to say this, await this set authority. In this set authority, you're trying to, let me show you what I'm doing. First of all, I need the connection as always, and the owner, which is the payer of the gas fee. This is the token that we're trying to operate on. And the current mint authority is this owner dot public key, and the authority type, okay, is mint token, and then you want to make sure that the new mint authority is null. So when you do this, that means that entire project is secured because it doesn't have any mint authority anymore. So nobody can come and mint. You basically just shutting down that minting ability. Nobody can mint new tokens anymore. So that is one. But if you say close, that means you can still open it back. You get that. So, but this new mint authority being null, is going to ensure that no future minting can be done here except the circulation of the already existing token of that project. So you want to say const signature. So this is signature. You need to grab that signature, and the signature, and you want to just log it off. So this one is just very simple. We just log and say that finished, set mint authority, and you just want to do this log, call this function and pass in the mint authority token mint and the owner, and just say mint authority disabled. With this, you save that and you run this last step, which is 5. Okay, let's run that. So we can see here that we've disabled that mint authority, and if I refresh this, you can see that this is how it is with a mint authority, but when I refresh that, the mint authority should be gone at this time. You can see that it has only 2,000 tokens in supply and it's fixed, and the mint authority is not there. Nobody can come and manipulate this token anymore. So this token should be trusted, right? So now, okay, I want to do something again on this. So we have all these things set up, but there is one more step. Let me come to this metadata. I want to give it version 2. This is v2. Okay, so that I want to distinguish it from the other one. Now I'm going to come to this place, package.json, and this token mint. So currently this is the address of this token, as you can see here, which is this, right? We want to create an entire different new one. We want to run that command in one go. And that is why I set up this particular command here, say called launch. So this launch constitutes all the scripts, like this one deploys, and then chain it with this one that creates associate token account, chaining it with this one that creates the metadata, chaining it with this one that mints 1,000 token to the user, and then chaining it by disabling that. So we just want to run that entire thing one time, and then the project should be set. So I'm going to come here. I'll say yarn launch. Let's run that and let's see this thing in action. So you can see all this command that was given. So these are the series of commands that are going to be taking place. So you can see that it has created a token, and you can see deploy the new token. You can see the address. You can see that it's performing it's attempting to create an associate token account, and it's just failing. Okay, it's attempting the 5th time, and it succeeded in the 5th time to create the associate token account. So after now, it's going to go into the next phase, which is to create the metadata. All right. So this is the associate token account. It starts with a C. So you can see that metadata, metadata, the token metadata has been created already, and has been set up. You can see that is going into the next phase. So, okay, now we had an issue because maybe the way I spelled this was not correct. So I need to make sure that spelling is, see, it's not correct. I call it disable. It should be disable. Disable. That was just a big mistake. So if I come here, disable. Okay, so I'm going to copy this disable. Okay, that should be correct. So let's run this again. All right, so it's going to create totally from scratch. All right, so just give it some time. Okay, it has deployed. It's attempting to create the associate token account. It's tried 4th attempt, 5th attempt. It's trying. It's trying on the 6th attempt. You see how unpredictable this is. Trying the 7th attempt. Hopefully this will work on this 7th attempt. This is one of the reasons why I gave it up to 30 attempts, so that you will not have to experience some of this craziness that I saw trying to work on this project. So the associate token account has been created now, and the metadata has been created as well, and it's going for, I think this should be the last phase. It's minting now, so it has minted successfully, and now the last phase has to disable that token account. So it has disabled the mint authority. So with all of these procedures happened, if you come to this token mint, you can see that this is the token account. If I come here and enter here to search it out, so this is it here. You can see that this is V2 here. You can see that it's 1,000 token and it has been disabled. So that is just fantastic. All of those things well streamlined, is fantastic altogether. I like it, and I hope you've been blessed by this angle of it. Please, if you're still watching up to this moment and you have not subscribed, please, I need you to hit that like and subscribe button. Show some love into this tutorial, because a lot of work has been put to make things easier for you to work with. So please just hit that like and subscribe button and smash that notification bell, okay? So in the next part of this project, we need to then start doing some minting, okay? In fact, we need to display this information about the balance of the user and also the recent information that transfer that happened there, before we proceed into minting token. So I'll see you in the next part of this video. All right, so let's head into the next phase and load some balance, okay? And yeah, let's just see some information about what we're dealing with here. So for doing that, we need to create a new service, call it blockchain.ts. So this blockchain service will be used to gather information, such as when we want to retrieve information from the blockchain and so on. So let's get this one first, called fetch, mint history const fetch sales history. Okay, so we're gonna say async, and it's gonna require some stuff, parameters. These are the parameters it's gonna need. It's gonna require a connection and a public key. Okay, so I could import this connection. I could also import this public key. Those two elements are needed, and we need to grab the first 10 records under this public key. You understand that? So we can call this address. Okay, so we want to get the first 10 records from that particular address. So sales could be happening, a lot of records taking place. After we're taking that address, the next thing we want to do is, anyway, this was more designed for testnet situation. So right here, I'm going to paste this. This right here, I use it to determine whether I'm working on a testnet, I'm working on a mainnet, or a devnet. So I say this connection.rpc endpoint dot includes devnet. If it does include devnet, I want the cluster to be returned to be devnet. Otherwise, if it's testnet, it should be what? But if it doesn't match any one of those, it should be what? Mainnet. So this is how I know which cluster I'm working with. okay, because when I'm forming some URL links later on, is going to really, I'm going to need to know which network I'm working with so that I can construct my transaction URL back to that particular cluster. So that's why I'm getting that. So we need to filter the transaction so that we will get the accurate one. So I need to call the transactions first. So we say these signatures, we map through that signature. We're mapping through this signature, and for each signature, we are getting, we get the transaction record of that signature and want to get only transactions that have been finalized, and we're using this max supported transaction version as well to be 0. So we want to filter it. So for each one of those transactions, we're calling the network. So this is one of the downsides, because I have to make like 10 calls, you understand? So that's why I feel like setting this to be 5, so that, I don't want to call more than 5 transactions, so that it will not be too much. So I'll put this, but I need to put it on a promise, so that this transaction will be done first. Okay, so I could say const transactions, okay, is equal to, I'll put it on a promise. I want to wait till this part is completed before I proceed more. So promise.all, and then you are pasting this to enable this filtration to be completed, and I will store the result in this transaction. Okay, so after I've done this, I need to filter for main. So the kind of transaction that I want is transactions that has to do with minting and transactions that has to do with transfer. So I will call on this, I'll say these transactions dot map, okay, and for each transaction there, type of any, okay, I want to grab this information, okay, about that transaction. So we have the messages of any type, okay, and this would be this tx.transaction.message. There is a certain information there called .message. The instruction is .instruction. The account is .account keys. So these are various people that partook of that, transaction. And then the signature is, the .signature, the transaction.signature. Okay, so those are the information. I think this can be at the top here, so that we know that these two are of the same type. Why these two are of the same type? So we're grabbing the message, the signatures. The signatures are the people that partake of this transaction. The instructions that are part of this transaction. Because each transaction can have multiple instructions inside of it. And then the accounts that are part of this transaction as well. So those are the things we're getting. And the next step is want to get the relevant instructions. So the instructions that are relevant to us, I'm going to show you this in a moment. So I want, transaction that has to do with mint2, and mint2, transfer transaction and minting transactions, okay? A minting instruction, sorry, these are now instructions, this is not transaction. So I'm getting the relevant instructions that has to do with minting, and instructions that have to do with transfer. So for each instruction, I'm looking for each instructions, I'm looking for instructions that has to do with, these are just some conditions to be met, okay? It doesn't make much sense, but this is the decoding of this helps us to know which kind of transaction or instruction that was, okay? So we'll call on this decode instruction type. So this instruction type here, that is this data.instruction type. So we formed a function that will help us to decode that, instruction, and it's going to make a lot of sense to you just in a moment, So I'm going to paste this here. So this decode instruction type. It passes in a data, which is a string, okay? And we're using this base 64 F58 package that we installed earlier. So we can come back and say import, that is BS 58 from BS 58. So we're importing that one. So we use this BS 58 to decode this string. This string contains data, essential data, okay? And in that Solana decoded structure, the way it was structured, we know that this instruction, the first member of that, it becomes an array. You should know this, becomes an unsigned, integer 8 array type. So that means it contains several, instruction, and the first element there is called, instruction type code. So the types of instruction that was carried out, the code for them. So the code could be 3, which indicates transfer. It could be 7, which indicates mint to, because those are the kind of instruction that we're looking for. But if the default is unknown transaction, so we're going to get all this transaction, and anyone that matches all this transaction, then we'll return it. That will become part of the relevant instructions that we're looking for. So after this, you want to perform some checks, additional checks, okay? So the additional checks here, you're saying if there is a relevant instruction, okay, and the signature length is greater than 0, that means there are signatures, there was some signing that happened here, then we want to get this couple of information. We want to grab this information from it. So these are the information we're grabbing. The receiver index, okay, so basically this is like the information about the receiver of this particular token. So when you're buying token, whom is receiving this token is the receiver. So this is the index that is responsible for that. And then we're grabbing the receiver public address out of that. So we're calling on this account, okay, the accounts here this account here, which are part of those people that signed the that were involved in that transaction, the account, and then we're passing this receiver index, and we grab the string version of this, receiver, and then the amount, we need to decode that because is in this relevant instruction dot data. There is also a data there which we need to decode, which is where this function that is called decode amount comes in. So this decode amount, it takes in the data with a string, and the decoded data. You see how technical this is? In the outward, when you look at the entire thing, this simple view, there is nothing here. But now you're seeing how it goes deep if you want to truly get something streamlined as this. Okay, so that is just what you should know, that it's not by power, it's not by might. You understand? So now we need to also decode that string, which we're using this base PS58 library, and we decode it. And when you decode it, it's now what is called a data view. Okay, I think this is part of JavaScript. So data view helps you to view the data. So basically, you're getting this decoded data, the buffer of it, the decoded data, the byte offset of it, and the decoded data, byte length of it. I understand. I knew a lot of struggles that I passed through to get this whole thing to make sense in this format. But this will really help you to dig into the Solana ecosystem. But if you follow this thing step by step, as I'm doing this thing, then you will not have this issue on useful issues. Please, you've seen how I'm working this thing. I'm going through this process one step at a time. I would really appreciate that you go through it the same way, because many people, once they just get small mistake, they will just, like saying it's not working, but it's working. I'm working on it right now. Like, look at it, it's working. Okay, so make sure that you go through the Git repository. In case you have any issue, you consult the Git repository so that you can compare your codes and resolve your errors, because I may not often be around in terms of be available online to answer your questions. I may be very busy. So you should just be able to recognize that. That is why I'm doing this thing very, step by step with you like this. And please, if you have not subscribed, don't forget to hit that like and subscribe button, okay? It's very important. You're learning here for free. All right, so the next thing you want to do, you want to get unsigned integer 32, you basically converting this to this format. That will become the amount, then you return this amount. So that data will be decoded with this instruction here. And that's why this decoded amount is now what we're seeing here. So you decoded the amount you use in purchasing. That token amount is the token amount I'm talking about. It's not your Solana, it's not the Solana account amount, but just the token amount. That's what we're using. So we decoded it here using this function below. And then the transaction link, this will give you the link to where this transaction is in the Explorer, okay, Solana Explorer. And this is the address link. It gives you the link where it is in the Solana Explorer. You see how we use this cluster? This is because we've been able to define a way to recognize this, to make this, a deal. So we get all this useful information, okay? So we want to return those information now. Okay, so I'm going to put it here. So these are the information we're returning. We're returning the receiver address, that's for sure. We're returning the amount, but we're dividing it by 100. We need to divide it by 100 so that we can get the accurate representation on our own end as it is also on the Explorer. So we're making the information to match each other. All right, so this signature basically gives you the signature, all right? So we're grabbing the first signature, which will point to the location of that, of it on the hash, the hash string of it on the Explorer, putting the link and the transaction link and the address link. So those information, and then at the end of the day, if this is not matching, we just want to return null. So if this thing didn't work out, we return null. So which we can also put in an else string, but it's all the same. So now these transactions that we're filtering and mapping through, they need to be put into a variable called sales details. Sales details. Okay, so we're putting that, the result of it in that place, in this variable called sales details. But now, still on this sales details, we want to filter this because we want to filter any transaction. We want to filter transaction, the details. We want to check the details of that transaction if it's not null. If it's not null, then it should then return that as part of what? The mint, history. This mint history, I've not defined this for you, but if you come to this utils, types here, I've defined a simple type which you have, it capture all the information about a sales history. So I could call it sales history. So we have receiver, which should be a string, or it could be, I don't want to make sure that it's a string. It could be it could be in a public key format, so we want to keep it like that. And the amount, which should be a number, is a signature, which is a string, and transaction link and all of that, all those things are string. So now I'm going to come back here and say sales history. Okay. So an array of sales is history. That is what should be returned at the end of the day. So, and afterward, we want to just return this. Return the sales details. So this is what is going to be returned. We need to make sure we export this. Export this sales history. Okay, this is getting interesting. So at the end of the day, we want to then come to the page, the home page here. So it's in this home page that we are going to invoke. You see this place? This is where, instead of us getting this data, like these are just dummy data, which is this tray that is being displayed here. Instead of getting this dummy data, we just want to grab this data ourselves from the blockchain, from the Solana blockchain. So to do this, we need to come back here. Then instead of grabbing it here, we can say what we want is sales history. I don't think I spelled this properly. It's supposed to be capital sales. Okay, let's do the same here. So sales history, and this can't match. Okay, so we need to make sure that it's the proper one that we're grabbing. So we want to call this await function, call on this fetch sales history. You know, in order, let me remove this for now. Okay, that is not helping us. So in order to, we need two things. We need to grab the sales history. We need to supply the connection status and the token address. You can use the connection status, you can use the token address, you can use, you know, the owner's address. Any one of those address that you need can be used for this. So how do we grab the token address, how do we grab the connection information? So thank God we've never used this before, but now we're using it. This comes from, we want to say connection, const, connection, okay, from use connection. Use connection. This is coming from the wallet adapter, okay? This wallet adapter, where are you? You know, Solana wallet adapter React. So this is a function that is coming from there. So we use this function to get our connection. So we pass that as one of the data here. So that is a connection. The next one is the public key to that particular address that you want to get the histories from, what is going on, the minting and the transfer histories. So if you want that, we can grab that by you know, we can grab that. How do we grab that? Okay. You do know that we have this thing. I'm going to remove this tool here. So I want to import the address. Okay. I want to go to the services / this token main. So this place, this is where the address is. You can see this is the address right here. So we want to grab that. So to grab that, you can create a constant here. So const token mint address. Token mint address is going to be a new public key. You know that it's a string that we have here. This is a string, so we don't want it to be a string, so we can pass this address.address, okay, which is a string. Then it gives us in its format, which is the value in base 58. I don't know if you understand that. So it will give you the value of it in this BN, this, in this format which a public key normally is, you understand? It's not in string, it's not a regular string. Okay, so we want to convert it to the format which public keys are made in Solana. So if I pass this public key now, this is cool to an extent. It is not assignable to. So what we can do to aid this, we can say as sales history, an array of it. Okay, so I also want to pass in this. For now, let's just keep that. So let's see if we can do this. Okay, so any, or if we say sales history, it brings out error. So it wants any. Okay, let's give it any then. So we're setting this here. So here we can help this matter by saying sales history record. So an array of it. So I think if we do this now, nope, still not. Okay, so it doesn't matter. So let's keep it this way. So we have this here, and let's save this and see the result on the browser. So you see, this is the result. This is the only record that we have. This record came when we initially, transferred, minted, okay, a token. So if I click on this, it should take me exactly to where that transaction is on the blockchain. You can see that this was a transaction that happened. And you can see what happened here, that 1,000 TKC token was sent to this particular address. This is an associate account. And if I check this associate account, you can see that this is I have about 1,000 of it. And this account, this is the owner, okay? This is the owner of this TKC. This TKC, okay? And if you come to this TKC, you see that you will notice, let me make sure that you're seeing this properly because I don't want to block you. So you can see that this TKC has this 1,000 record here, and you can see the mint authority is no longer here, but if you come back to this place, you can see that this transaction that was minted, for TKC, version 2 goes to this particular address. Where is that transaction again? Let me go back to that transaction. Okay, this is the transaction. You can see that it goes to this particular address and it's 1,000 TKC. So that is it. So that is it for this place. We'll be able to read information. How about grab the balance from the blockchain as well and display into this project so that you can be seeing how the balance goes. Okay, so I'll see you in the next part of this tutorial. So before we even start minting, we need to, not minting, purchasing token, because we've already done all the minting and all that. So we need to read the balance first of each user. Okay, if you come in, we'll be able to read your balance and all that. So that's what we want to first do. After we do that, then we proceed with other, the final step of this game. Okay. Not the final step though. I think I'll still have to bring Redux into it to make the entire thing come together. All right. So let's get into the game. Okay. So I'm going to close out from all of these, and I'll come to these services, blockchain.ts. Okay, after we're done fetching this, okay, I need to create a function called getTokenBalance. So this function called getTokenBalance will
we take a connection as always, a main public key. So this is the address where the token is located on the Solana DevNet blockchain, okay? And this is the recipient public key. So this is whom is trying, the person that is trying to purchase these token from us. So those are the major information that you need, all right? And of course, you want to get the associate token of this person first, because some people that want to buy your token, they don't already have an associate token. So it's basically something as this. Where are you? Here. So I'm going to copy this line of code, but we're doing something like this, but I'm going to show you a difference now. So we want to get associate token, I'll call it A to E. This one, the problem with this, we can't use this particular function to getting an associate token here, because we are creating transaction object which want to load up all these things and fire it one time. So this particular process involve you creating, an associate token if it doesn't exist. No, we just want to check if it does exist and not necessarily having to rely on, on creating it if it doesn't exist. Okay, so we're going to use this one called just get associate token. Why this one is get or create associate token. So this is the difference. You need to import this from Solana SPL library. Once you import it, the first thing that goes in here is not really a connection. It's not really a connection, but the main public key. I'm going to remove all this and do it from scratch. So we have this. This is the main public key. That's the first thing that comes in here, followed by the owner's public key. So the owner will be the person that we're trying to check their associate token account, which is this recipient public key. And we don't want this allow owner curve. We just want it to be false. Okay, it's not very useful to what we want to engineer here. And there is something called token. Right now we could with this information, but want to add some, more default Solana, IDs, you understand, such as this token program ID and also this associate token program ID. These are some programs I think that is responsible for managing this whole thing, you understand, just like we have with that Metaplex, that what they call it, metadata, program that was responsible for creating metadata programs. So right here, you see that if I hover to it, you see that this is the associate token program address, just like we have with that metadata program ID. This is the address, and this is the address for token program as well. So they are both different. So we needed to make that distinction. So as of this point, you will retrieve the associate token account. Please note here that this thing does not interact with the blockchain. It just generates this information based on this data that you supply here. Then it will generate what it's deemed to be the associate token account. Now, the next thing you need to do, you want to now check if this associate token account is present in the blockchain. Okay, so you say account info, you then pass in this associate token account. Account info, and then you consult the connection, the blockchain, and then you get the account info of this associate token account. Then it's going to return something. What is returning is if it does exist, okay. If it does not exist, it should just return 0, okay. So it should just return 0, that it does not exist. So we can just make this one line of code. All right.
So otherwise, it should proceed with grabbing the balance of this associate token account. Why we're returning 0 is because we want this, the return type is, a number. So it has to return something, whether it has or it doesn't have, okay? Whether it is located or it is not found in the blockchain. We're doing this so that to prevent errors. Okay, so the next thing we want to do is, but if it does exist, you can then call on this token account balance. You consult the connection. You see, this one is get account info. So if there is an account info for this associate account, it will if there is no account info, it will return 0. But if there is an account info, it's going to grab the token balance that that particular associate token account does have. Okay, and once it grabs it, we then just filter through and get, you say token balance dot value dot UI amount, the amount that can be understood from the UI perspective. And then if it doesn't have this, then it should also return 0, because if it doesn't have this, that means it doesn't have any token yet that it has minted or purchased of this particular token, our TKC token. Yeah. So this gets you, the balance of any associate token account that you're looking for. So you want to make sure this is exportable. You save that. Okay. At this point, you want to now come to the home page again here. So you see this place, instead of just making this 0, we're going to make it a different thing altogether. So we're going to say, we want to await this get token balance. You want to make sure that you import that. You pass in the connection, and you pass in the mint public key, which is this token mint address. Okay, and what else? The recipient public key. So the recipient public key will be, how you get the recipient public key is, we say const. So the recipient public key is any account that is currently connected, like this here. This is the recipient public key. So we want to grab that, and how we grab that is through this thing called use wallet, and it's coming from this React adapter. All right. So Solana React wallet React adapter. So you want to say public key. Okay. So there we go. Now we then have to pass this public key here. All right. So, but this public key could be null. So how we ensure that this is done properly is if there is a public key first. Okay, so we can say that if we have a public key, then it should do this. Otherwise, else it should set balance with this. The balance will just remain at 0 as it already is. Is 0 right here. So it should remain at 0. So this will help us to make sure that we have a public key before we can make that call. So when we save this, you see that this particular account has 1000 DMA, but I need to just change this to TKC instead of DMAs. So I could do that by coming to this balance. Okay, let's see, I'm passing the balance in here, is a number, and I'll say TKC tokens. Okay, so when we do that, you can see that. Fantastic. And what we want to do, later on, what we will do is, as we change various wallet address, it's just going to be, updating or swapping that. So that is how you read balance of the token from, the blockchain. So in the next part of this video now, we'll then start operating and buying tokens. So I'll see you in the next part of this video. All right, so let's buy some tokens. All right, so I'm going to just close all this. And we need to come to these services here. Okay, so let's create
another function. This function is going to be called buy token. All right, buy token, and there's a lot for you to know about this. In buying token, you need a connection as well. You need that is the token public key. You need the owner, which is a key pair. You need the recipient. The owner is the one that actually have access to that. The owner is the one that has the tokens that you're trying to buy from. Okay, so anybody can sell their own token. In fact, let's say a mint happened and people purchase their various tokens, and after mint was over, you can set up you can just come here and change, you just put your key pair in as the environment variable here, and you also specify, you also specify the token URL, the token address, and make sure that you're connected to the right blockchain network, okay, whether mainnet, and then people can actually be purchasing this from you. You can even set the balance, how much you're selling each one of your token. All of these things can be done by you. So here we go. So I need to make sure that this owner is a key pair, so I'm importing that. So after this is also the recipient public key. So this is a person that is going to receive the tokens that will be purchased. This is the amount that he intends on buying, and this is the main cost. This is how much it costs to purchase a token. So I don't think the best thing is to call the main cost. We can say sales cost. You understand? Sales cost, because we are trying to sell the token. We're not trying to mint it. We've already minted all that. Okay. So the next thing you want to do is to make sure you import this transaction, because it's a transaction object that needs to be returned at the end of this particular function. So the first thing you want to do is to create a transaction object. So transaction is equal to new transaction. Okay. So then you want to immediately set the fee payer. Okay. So you say transaction dot fee payer is equal to this recipient public key. So the person that is trying to purchase is the one that will also pay for the transaction. So the owner is not paying for the transaction. The owner is only, adding signing the transaction along, because if the owner does not sign this transaction, they can't purchase from him. So it's very important that the owner signs the transaction. That is the only reason we have this owner key pair. If not, I will just add only the public key. So after this, you want to get the associate account of the receiver, which is the person that is trying to purchase this. So we can just copy this line of code, bring it here, and say ATA, say receiver ATA. So the receiver ATA, you put the main key, main public key, the recipient public key, associate token account, okay, and that is it. We also need the sender public key, ATA. So the sender ATA, so I'll say sender ATA. Now this will be the owner dot public key. All right, so that is the two. They need the associate token account for them to be able to make the transaction, because you don't send to their default Solana account wallet address, but the associate token address. Okay, so you grab this. Okay, we know that this is not going to produce any error because these things are not consulting the blockchain yet. So then you want to add a transaction. We'll start performing some things to add some transaction, because there are many things we want to do here. So for example, we want the transfer transaction. We want to be able to, we want you first to pay for this transaction, because we have sales costs, right? So we have an amount that we're using in selling a token. So we can then specify we'll create another function for this. We'll call this function add Solana transfer instruction. Add Solana transfer instruction. Or we can just call it Solana
Solana transfer instruction. Okay, so, and this would be the sales cost. Okay, sales cost. So this is from the public key. This is the means to the public key that you want to send to, and then we then perform that Solana transfer instruction. So we can say const, instruction. Instruction is equal to, there's something called system program. It's something that comes with the Solana Web3 package. This system program enables you to specify an instruction, such as a transfer instruction and so on. If I click here, you see different kinds of instructions, like instruction.transfer. Look at a transfer instruction, look at creating an account instruction, and so many other kinds of instructions. So what we're targeting is transfer instruction. And in transfer instruction, it takes in an object. The first object it takes is the from public key. This is supposed to be like from public key, an object, but since the name and the key, they are the same. Okay, so we can just do this. And then to public key as well. And lastly, the amount. Okay, the amount has to be specified in what is called lamp port. Lamp port is like the smallest denomination of the Solana token. Just like with Ethereum, you have WE, which is the smallest denomination of their cryptocurrency. So say lamp port. Lamp port is going to be the sales cost, multiply it by the amount of tokens that they want to purchase, and then multiply it by the lamp port per se. This is, I just imported it from this place as well, this Web3 package. Let me streamline that. So those are the items I've imported. So now, after all these things, then I can just return this instruction. Okay, but I can return this instruction. So this is it. I can let me just make sure that it's well spelled. Instruction. Okay. You can simply just return it here as well, and save yourself this call. But for simplicity, this is an educational content. It has to be written in a highly understandable format. So, so with this is Solana transfer instruction. Okay, I will then add this instruction to this place. So I'll say I'll consult this transaction, object that we created. Dot add. Add is a function that you use to include a transaction. Remember, this returns a transaction that we have prepared here. So I will say this Solana transfer instruction. And so what does it need to perform an instruction? So where the account that is coming from, which should be these. Remember, here what you're adding is not the associate tokens, okay, address, but you're adding the regular account information, okay. So we're going to say the recipient public key is where the money is coming from. So recipient public key, the money is going to this owner dot public key, all right, and the amount that we want to transfer, the amount, that is how much this amount here is different from this main cost, okay, the sales cost. The amount is how much Solana token that you need to purchase one of our TKC token, okay. So the amount is going to be there, and lastly the sales cost, okay. So you need this information, okay. This will add that transaction to this transaction object, because this Solana token transfer, it returns a transaction object. It returns an instruction, okay. That's what it returns. So at this point, you can, this is where we then check some information. All right, we check some information, and please make sure you you arrange this thing in the order which you want it to be. First of all, you want, you can decide to create an associate token account first, and then you make the transfer, before you charge the customer, before you actually, but it doesn't really matter. I've tested it, they kind of both worked. So I'm going to add this transaction fetch, which I've already done. Now I'm going to test for the associate token account. Remember, we had this method here where we did check for this, if the account does exist. So I'm going to take that as well. I'll come here. So what's happening here is I want to check, because now we are sure that the sender does have an associate token account, because there is no way he's going to have some tokens if he doesn't already have an associate token account. But we want to test for this receiver, okay, because we don't know if this receiver already have an associate token account. So if the receiver doesn't have an associate token account, which is talking about if it doesn't have an account information, then I just want to log out a simple information, on the console saying, we'll include fee for creating, say receiver ATA, okay, receiver associate token account for this, So we'll do that, and then we actually add this say transaction dot add. Then we need to add that associate token account, a transaction for creating that. So we can actually make that a different instruction as well. So let's make that a different instruction. To create that instruction, you will need this add. You just simply say create ATA instruction. Create ATA instruction. So you're creating an associate token account. So you literally need the payer, the ATA, and the mint public key. So the payer is whomever is going to be paying for this transaction, okay? And the associate token account is going to be the token account that is intending to be receiving some of our, tokens, and the mint public key as well that points to the token that you're trying to create an associate token account for. All right, so you can then say const instruction is equal to, there's an instruction for creating associate token account, which is create associate token account. It's coming from this SPL. Account instruction, you need to, not this one, account instruction, this one here, say create associated token account instruction. So you need to get that imported, and you pass in the requirement. So the first thing is the payer, who is paying for this, okay? The payer, we pass in the payer object here, okay? The next one is who is going to be the owner of these this associate token account. Is going to be this ATA that we supplied here. And then lastly, you say, okay, not yet lastly, who is the owner of this associate token account, is going to be this payer as well. So the payer is also this the owner of this associate token account. And lastly, which token address do you want, it will be this main public key. So these are the information you need to create, an associate token account instruction. So with this will be an instruction that has been arranged, and then you can simply just return this instruction. I'm going to close this. I'm sure I kind of missed this. Let me expand this. I don't know why this is not breaking properly, so that my face will not be covering this. I'm sorry if my face has been covering this for quite some time, and I didn't take note of that. And that's why I'll say also adding the GitHub repository so that you can check this code yourself and see what I'm talking about, okay? So that, you know, if you didn't get it properly, you can look at it there, go back and look at it. Okay, so this is cool. And one thing I could do to help myself here is to break this into, I could break this into, oh, it doesn't still help any matter, you know, so I'm going to close that. So now, okay, so now let's create that ATA. You can see ATA instruction. So let's create that. Let's add that. So we're going to add it here. And when we're adding it, you need to supply who is paying for this transaction is the recipient public key. Then, which ATA are we talking about here? The ATA is going to be the receiver's ATA. And then, which token are we talking about? We're talking about the main public key. Okay, so those are just the information you need. So this is the main public key here. So you have that. So we're still moving. We're not done yet. So lastly, one more transaction. You see, we've added a main transaction already. This is one transaction. This is another transaction. And we need one more transaction. Hopefully that will be enough. Okay, so we need one more transaction. So the last transaction here is the transaction to transfer that token, the amount of token that they want from the owner to the buyer. You understand that? So that is what is happening here. So we want to say transaction dot add, and we need to create a special function for this as well. See, add token. You know, this is token transfer instruction. So you need the sender's ATA, the receiver ATA, the owner public key, the amount that you're trying to transfer from the owner to the receiver. Okay, so those are the information that you need, and then you can then construct the instruction. Instruction is equal to an instruction called create transfer instruction. Okay, see, it's coming from this SPL token library, so I'm going to import that. And what do you need? So the source is going to be the sender's ATA. Okay, the destination is going to be the receiver's ATA. The owner's public key is going to be this owner public key here. The amount is going to be this amount we also specified. But I want to multiply that by the math, because there is a certain format that we use we need to specify, you know, the power ratio, because remember this token has a decimal place of 2. And so we need to specify this expression so that this can be multiplied properly. And when you mean one token is actually one token. Okay, this is a weird way of putting it, but it actually solves the problem. And you know, if you want to do multi-signers, we're not doing multi-signers, so I'm putting an empty array. And you also need this token program, you know, ID. All right, so those are the items that you need to create a transfer instruction. Then you return this instruction. At this point, you can then pass this token transfer instruction here. Then you need to pass the sender ATA. So you pass the sender ATA, you pass the receiver ATA, you pass the owner public key, you pass the amount, and that is it. So this performs the transaction. Now this transaction object needs to be returned as well. Okay, so return transaction. Whoa, that's a lot of procedure, right? So you need to also export this function. at the end of the day. So you save that. Now let's go to the buy token component. This is the component that enables us to buy token, which is this component here. In fact, I'm going to change the name of this button to align more with what we're doing. So we're saying buy token. So we specify that there. So here we go. Before we actually buy a token, I want to make sure that also that if I don't want the owner to be able to buy tokens, okay? So I'm gonna perform some things here. So this function enables us to buy the token. So let's go on with it and work on it. So the first thing I want to do here, I want to say that if we don't have a connection, so in fact we need to make sure we have that connection first. So we're going to say const, so use wallet, and I will need the public key and also a function called send transaction. They are going to be needed. We need const, another one. This one I'm going to call it use connection. Then we'll get something called connection. So you need those two. Maybe I'll send this like this. So now I want to make sure this is how we know which network we're connected to, and this is how we know the public key of the currently connected wallet address. So I want to say if we don't have a connection, or we don't have a currently connected wallet address, then this should just silently return, because there is really nothing here that can be done. You get what I'm saying? So we need that. Okay. Another thing that we want to make sure that the token mint address is present. I think we can get this from the previous ones that we've done already. So if I come, let me look for it, page index. Okay, yeah. So token mint address, I'm going to copy this line of code. I want to make sure that it's already here. Okay, it's coming from address. So I need to import this address as well, the way it was imported here. Okay, so this address. Okay, so I need to also import this public key. So now here we go. We'll get this token mint address. So if we don't have a public key for the token mint address, then it should also silently return. I think with a message, it will be much appropriate to be returned with a message. This saying, please provide a token mint address. This one say, please connect, please install or connect your wallet. Connect your wallet. All right, so that is cool. And lastly, we also need a token owner. Okay, so I'm going to say, for this token owner, I have to import it. So I'm importing it from this. No, I don't want to import it from this script. Okay, so I don't want to import it from that script. So I will have to grab it from the environment variable. Okay, so I'll grab it here. So process.env.next public key pair, And so if there is no token owner, you should simply just log out. Please provide a token owner key pair. Okay, token owner key pair. Very important. So these are some precautions that we needed to put to make sure that, we're getting the right information. All right, making sure that everything is ready before we
we push forward. You get what I mean? So now the next thing you want to do is you want to convert that token key pair, because if you do remember, I don't know if I can access this here, .env. I don't know why this doesn't just say code.env. Okay, so you see that this is a string format. This is a string format, and this is not going to be helpful to us. We need to get it in the right format. To get it in the right format, it has to be in unsigned integer 8-bit array, okay? So we need to get it in that format, and how we do it is through this method here. So we now have this owner array, unsigned integer 8-bit array from this token owner dot split. You split it in wherever you have a comma, okay? And after you split it, you then convert each one to a number, okay? So you convert each one of this item to a number. That is what is happening here. So once it is converted to a number, the next step you want to do is to say const simply owner will be of a type of key pair, okay? And you say is going to be equal to this key pair dot say from secret. So you want to convert this from the secret. So whatever secret it is, you need to pass this owner array, okay? And it will convert it to a key pair for you. Then you also need to make sure that we have this recipient. So whomever is receiving this, so okay, yeah, I don't think this is really necessary, okay, but let's just move forward. Then you need to create a transaction, okay? Say const tx, which is transaction. You see, in the front here, when you just come here, everything looks simple, right? But there is a lot of technicalities that goes into making sure that functionality that you're looking forward for actually happens. So this is why we need to dig in and do a lot of what do we call it? What was the name again for that? Research. You understand? So say await buy token. We're importing it from this blockchain service. Okay, so we're passing in the connection, right, as the first item. Remember, we're passing in the main public key, which should be this token main address. You also need the owner, okay, which we just created here. The owner is a key pair. You also need the recipient, which is basically the public key, okay? And you also need the amount. You want to make sure that the amount is a number format. So you want to make sure you convert it to a number. And lastly, you want to make sure that you have a sales cost. All right, so we don't yet have that, but you can create that simply here by saying sales cost, set sales cost. Sales cost can be 0.2, okay, 0.2. So let's say 0.05. Okay, so this is how much the sales cost is, and I could then substitute here the sales cost to be here. This is what we're using for selling each TKC token. Okay, so now you've specified, you've informed. This is going to return a transaction object, right? And then there is a function. Okay, we want to get the signature, so we want to say const signature, okay, is equal to await
we now have to consult this send transaction, this function here. Say send transaction, then you pass in this TX, which is a type of transaction, and you pass in the connection as well, and you pass in one last thing, okay, which is an object, the signer. Because if you don't pass the signer, you can't make that transfer because you are not the owner of the token. It belongs to another person. So we need to pass the key pair of this signer. So that's why we have needed this owner here. And once this is successful, the next step is to get the token balance. We first of all need to confirm the transaction. Okay, so we need to confirm that transaction. So I could just set the amount for us to be an empty string. So I'll clear it out and then confirm the transaction. I confirm transaction here is to say connection dot confirm transaction. Okay, and you want to pass in that signature, and you also want to pass in the status that you're looking for. You can say, finalized. Okay, the status, you want to get it, once you get to that state, and then you simply just grab the balance again, say const balance is equal to await. So for now, I'm just going to keep it here, but we still need to check grab the transaction balance and all of those things. But I can log out some vital information. Okay, so that will be, I can log out this transaction signature. Okay, so I think we can do that for now to just confirm if what we have purchased is correct. So let's do this, save that. See, if I enter 3, you see that this is telling me I should buy, but this belongs to me. I can't come and buy. I don't want to buy this, because I'm the one that owns it. So I have to put some preventions here. So first of all, we need to make sure that there's a public key, okay? Because if there is no public key, this should not go. And we also want to make sure that the owner public key, so this public key here, or public key, okay, is equal to the owner dot public key. So if it is this condition, it should be disabled as well. Merge not found. Let's see why it's misbehaving. Okay, this is inside this place. So okay, so I could shift this. Okay, I could cut this out and bring it here. Okay, if I do this, I think that error should be resolved. Okay, let's save that and see. It's refreshing. So it's saying, let's see that. So it seems to be okay. So let's say 3. Oops, it's still not vibing with me. So if I say public key dot to string and equate it with this as well, dot to string. Okay, now they are equal. So long as it is me, I cannot. So long as I'm the owner of this token, I cannot, I cannot come here and just, grab this token. You get what I'm saying? Like, I can't just come and buy this token if I'm already the owner. Okay, so, please note sometimes that this thing can be, a little bit tricky, like because of network stuff. I don't know if what I just did here is affecting it in a way. So send that back. So we didn't touch that component. I'm sure it's going to come back to its senses soon. So, which is, if there's a public key, then you should get the balance. Okay, so I guess it's not yet recognizing the public key maybe. So that is one of the things I want to show you. So what we need to do to solve this, I'm going to change my public key. I'm going to change my connection. I want to use a different connection to purchase this token. So let's go with number 1. Okay, so I'm connected to this. You can see that I'm actually connected because I've recently connected this account. If not, I will have to disconnect and connect with that. I see it's just automatically connecting. And if I refresh this, okay, it's still showing up here. So now let's buy, some token. Let's say we want to buy 3, okay, 3 tokens. Oops, so it's saying cannot be converted to big int because it is not an integer. So where is this coming from? So that should be this sales cost. So now let's go and look at that sales cost. We want to, okay, so let's try this. I'm going to remove this from a use state. I'm just going to call this const sales costs. Okay, so and revert this to here, save it, let's refresh, see, let's see 2 tokens. Okay, it's working now, and let's click confirm. So it's literally creating an associate token along, and it has confirmed the transaction. So if I do this, this is a transaction key pair. You can see that it actually created the associate token account and it confirmed that transaction. So if we copy this transaction and come here, paste it here, click here, you find out that we have that transaction successful and finalized. See all the ingredients that makes for this transaction. You can see that this is the account that got debited and this is the account that got credited. Okay, and this is the associate token account that got created, that got credited, and this is the associate token account that got debited, I think. So, and there's a lot of accounts here. Okay, so this is the owner's account, but just know that this is all the information that makes for this one transaction that we just created. Okay, containing all these various entities, So, token has been gotten, and if you look here, you find out that this is the associate token account. This one with 3 AU. So if I come here, look for the one with 3 AU, see, and you can see we have two tokens of the DMA. So it got credited into it. So that is good for it, right? Very good for it. So I'm going to come back here now. There's some things that we need to make about this token. First of all, it's not very responsive, and I don't know why this is not working out. You can see that this token just recorded a sales. Okay, so we need to make sure that this is working out and this is also working out. So, but for now, we've been able to buy token. Let's beautify this and make this more interactive so that when you are loading this site, everything will be dynamic, and you can see what is it called? When you want to buy token, you can see some spinners, loading stuff, things that could just help you to appreciate the process that is taking place. So I will see in the next part of this tutorial. So the first thing I want to add, to make this more interactive is what we call the React Toastify. React Toastify is going to really show us what is going on, the loading process. I mean, like the approval process, so that we will not be left in the dark. So this is part of the packages that we have here. If you look at this package, you find React Toastify to be here. So I've already installed it. You look at it, and that is just what it is. You can just do a little bit of a Googling on it. All right. So the next thing, you want to make sure that you get the CSS of it. Make sure you include it here. So this is the CSS of this React Toastify, and you also want to include its component generally here. So I could put it here. So this component is quite important, and I have to import that component as well. So this React toast component, I'm saying that it should be the position of where my React container should be, Toastify container should be in the bottom center of my web application, and it should auto close after 5 seconds. It should hide progress bar to be false. So that means progress bar will be showing as well when it is before it hide. The newest one should be on top, false. Close on click. So when you close it, when you click on it, it closes. It's writing is right to the left, and it pauses whenever you focus on it. It's draggable. That means you can take it to a different location, and it's paused on hover as well. And the theme is dark color because I like dark color. So I'm going to save this. Okay, so that is all I need to do there. Now, the next place I have to consult this React Toastify, I can literally just, change these items. Instead of doing a console.log, I could just do toast dot. I need to import that first from React Toastify, and toast dot warning. Okay, so instead of if I'm not connected, instead of logging it on the console, it will be a warning on the screen that just pops up, telling me, hey, you better do this or do that. Okay, so that will be it for that place. Now, you see this procedure here, or this procedure, I want to enhance it. I want to wrap it around the React, Toastify, so that it can monitor for the progress of my work, of the maintain or the purchase process. Okay, it's quite important that I do it that way so that it can increase the user experience. Okay, so what happened is, for you to use that promise-based, it's a promise-based toast format. So this is what I literally mean by promise-based, and you're going to accept a promise. The first element is a promise, and then the second element, parameter. First parameter is a promise. Then second parameter is basically the responses that you need. Okay, so I'm gonna do this. So we need a promise. So when you say new promise, okay, so this will be where we do all our stuff, and this promise returns void. Okay, and it's going to be an asynchronous promise, and it's going to have a resolve and a reject. Okay, and yeah, so this is the function that is going to be executed. So this is a promise. It's take a promise and a response type based on the state of the state of the process that you're trying to monitor for, the state of this promise. Okay, so now that we have this, we need a try catch so that we can properly manage the situation. So if if it fails, we can just respond transaction failed and then reject with that error. But if it's successful, what do we need? First, we need to shift these here. We need to shift this in here. So I'm going to sign a transaction here instead. Okay, after I've shifted here, okay, and I want to set these set amount. I want to cancel out whatever is in that form, just clear it out. And after I've cleared it out, I want to then wait for this transaction to be successful. So I can do that here. Okay. Before I even think about logging out anything. So I've literally just shifted all the operations inside here. So this is not done yet. This is not quite done. So when we do this, okay, to an extent this could be done. I'll still come back, but we need to log out the transaction. So I'm going to log out this transaction. So instead of saying console.log, I'll say transaction signature. All right, and I'll resolve with that signature. But it's going to give me a complaint, so I'm going to give it a type of any, so that it won't stop giving me warning. So I'm going to save this momentarily here and come to the interface. So let me do this. First of all, also I want to change this to TKC token. So I'll come here, say history. I want to say TKC, save that. So we have TKC here. So now let me open this and let's buy like 3 tokens. Okay, buy. So for some reason, if there is a decimal place, it's having issue multiplying decimals. Okay, so I will put a parameter there to secure that operation. But if I say 4, let's say 4, it's going on. So first of all, you see this thing is showing approval. Okay, I think I'm trying to bring back that, but it's not showing. So now let's go back to again. Let's see. So one of these elements is, if I put 3 here, it's giving me this issue. Why is giving me this issue? Because it has a decimal, it has a number. So I need to convert this to a whole number as well. So I think we have a way of making sure that everything is a whole number. We can do that in this blockchain space. I don't know if, let's come here. We need to convert everything into an integer. So this whole operation, say pass argument of a type of number is not assignable to the type of string. So let me see if I do this to string. Okay, let's save that and see if this is going to help. Okay, so see that, oops, cancel. Request source is unavailable. Let's try it again, 3. Okay, so let's buy 3 of that. So click on confirm. You see this approval is waiting, is showing up, and once transaction has been confirmed and finalized, it's going to show up in the, it's going to be completed. Okay, you see transaction was successful, and you can see this transaction URL. This is great, and with this you're good to go. You can check the transaction here. You can check the transaction here to see how many tokens you purchased. So see that it's 3 tokens that was purchased. You get that, so, or that was bought. this is good. This is a very good thing, and it's showing you the progress. And I think if you refresh, the token will be listed as part of what you just, the transfer that was just made. Okay, it's not yet. So in the next part of this video, I'm going to proceed further to add some UI element here. And after I finish doing that, then we can take care of any lag that is happening in these balances. Okay, so I'll see you in the next part of this video. Coming back to this place, I think we're having an issue with this. Has not exported member. What? Let me clean that up. Say sales. So that's the correct one. So it has not been recorded before. So now there is one more thing, one of these UI elements that we needed to add. Okay. This UI element is called a skeleton. Okay, it's a skeleton. And I think if we visit the one online, if I say, let's visit this one online, Solana tokenized project. So you can see this UI element that is showing up here. Fantastic. So that is one of the things that I wanted to add here. So let us add it. Okay. For us to add it, we'll come to our app.tsx, sorry. We have a package for this already, and that package is called React Loading Skeleton. React Loading Skeleton. So that's the package. We need to include its CSS here. Okay, after you've included that CSS, you can come to the index page. Here, we're going to add some skeletons to enhance our view. So, for example, for this balance, showing of balance, and this mint history, I don't just want to put it like this. I want to do this. Okay, so let me import the skeleton. So, I'm adding a skeleton, but in making sure that it has a margin bottom of 2, and the height of this skeleton, since the height of this card is a little bit higher than the height of these ones, so I'm giving this one a height of 70, just one skeleton there, and then here I'm giving it doesn't have any height except the default one, and this number of the count is basically 5, so it's having like 5 information there. So let me save that. And when we load again, I think it should give us that kind of view. Even the balance is not showing up. So you can see that is a lot more cleaner. So the balance is not, I don't know why it's misbehaving, but it shouldn't be misbehaving, okay? So that is cool for that particular UI spinner. Now we also need to add something here. Okay, so for this balance, we need to come back to the balance. And in this balance, we're using this identicon. The identicon is supposed to reflect whichever wallet address that is connected, okay? So we want to grab the wallet address, which is this. We want to grab that. And you want to import this. This will give you information of the current wallet address that is there. So instead of putting a random string here, we can then put the wallet address here. So if there is a wallet address, it's going to give us the color that is just directly associated with that wallet address. Otherwise, give us the color for an empty string. So when we save that, come back here, you see that this token has a different one, and if I'm connected to a different account as well, it's going to show a different vibe altogether. Okay, so this is cool. And for now, we kind of have everything. One more thing we want to do before we conclude this section. You see this, let's come back to this place. Whenever you're minting, you want to grab that. I think we should do this part because I'm about to integrate. I want to integrate, what's it called, Redux into this, so that as I'm buying token, it can be listed here and the balance can be topped, simultaneously without me having to wait and a lot of, having to refresh this page. So the components can be speaking with each other. So that's what I want to do in the next part of this video. So see you then. All right, so there is a step that we needed to take. You see, whenever I buy some token, I need to make sure that my account is updated. So that is one of the things that we want to achieve. All right, so to achieve that, we need Redux because these are different components and we need to be able to communicate with these three components at once. So let's jump in. I have Redux installed already, which we have Redux Toolkit, right? And React Redux. These are the two packages that I'm going to be using to communicate with the multiple components that I'm dealing with here. So let's jump in. The first step you want to do is come to the root of this project and create a new folder. You want to call this new folder store. All right, inside of this store, you want to create another folder called states and another one called actions. All right, so inside this one, actions and state. So inside states, I want to create another file called global states.ts for TypeScript. And now in this global state, I want to, basically what I'm doing is I'm creating an object that is of a type called global state. I'm making it exportable. All right, so global state, and it has a mint history, but I want to change this to sales history, which is an array of sales, and balance, which is just a number. All right, so I want these two information to be there. This is a TypeScript, and we haven't defined it yet, so we need to go ahead and define what that type literally means. And you can see now I only have one type here, but there is a global state and this type here. Okay, it takes in this sales history, an array of sales history, and you can call this sales history. All right, it's a type of sales history array, and then balance is a type of number. Okay, and I also need to specify this thing called root state, because it's going to be useful for me to access the content of my global states and every other state within my Redux application. Okay, let me save that. Okay, after this, you come here. Now let's import this here. Okay, and you see that everything is all good. That is all we need to do for this state. And we'll also have an action script. So say global actions.ts. Global actions.ts. In this global action, I'm going to just copy and paste this exported object. So it's called global actions, and this will be set sales history. I need to import it first. I also need to import this global action. It's a payload, type descriptor, and you also want to make sure that this is sales history item, and this should be sales history. Okay, so and this balance can remain the same. So what is happening here is that this is a function that we update the information in our, that will update this state. Okay, and this action will update this other balance state. Okay, that is what it is simply doing here. Okay, we are making sure that the actions payload is actually a type of sales history item array. Okay, we're making sure that this payload is a type of number so that the correct data type can be stored in this variable, and that's one of the beauty of TypeScript. All right, so we have those two things structured. We can close from that. The rest of this, we can create another file, call it global slice.ts. So in this global slice.ts, we're going to use to bundle the global state and the global action that we just defined. And how you do that is you simply paste this. This is an object of it. So we needed to create a slice, and we're creating a slice. And the name of this slice is called global. And the initial state will be this global state, and the reducer is going to be this reducer. And how we do that is we basically imported global states from this global state and gave it an alias of this, capital G global state, and did the same for this global action as well. The reason why we did that is so that we can then give this global action, this name, because we want to also export it separately, and we also want to export this global slices, the reducer, as the default export. So we're doing these two things because of we gave it this name, we gave it this alias because we don't want this to conflict. These global actions to conflict with this. I could only do this for this, but just to maintain consistency, I did it for both the state and the action. So this is just all you need to do for the global slice. And then lastly, for defining the content of the store, we need to create another file called index. Create that. Index.ts for Typescript, and then we paste this. This is an export. So this is a store object. We're just creating a store. We want to configure how the store should be. So I'm going to import it from Redux toolkit, and it takes a reducer, and the reducer is basically one that we've listed so far, which is this global state, and it's going to receive that global slice which contains all the information in it. So I'm going to import it from here, and that is all you need for creating this store. Now we need to then wrap our store this in our application. So when you come to this place, we need to wrap this entire thing with our store provider. Okay, and before I do that, I would like to come. I think I've saved everything. There is no file that is unsaved. So if I come here and use this Redux dev tool to check if there is a Redux component there, I need to clear this because these are like old information. I hope there is a way to clear this information. Reset. Okay, so I'm resetting everything. Refreshing. Okay. Now come back here. Inspect. Sorry. Redux. Not the bottom though. Let me remove it from there. Let's do it at this side so that you can see. So global state, main history. So it's still reading. It's literally reading the old stuff, but there is no Redux yet in this place, so it's reading the old information that I have already stored there, which when I was building this one online here. So I'm going to come back here. I will wrap this application with my Redux. That is what's called provider. It's coming from Redux. Okay, so this provider, I'm going to wrap this around it. So this provider receives an object called store, and this store is going to be that store object we just created, in this @store file. All right, so this store index file here. So we're putting it in here and wrapping it around our application. So with this thing is the application is totally refreshing. So when I check this again, you see that it's not sales history, it's not mint history anymore. So these things were now well balanced. So that is how it is. We've wrapped our application with Redux, which is cool. But that is not all we need to do. We need to start having them communicate with each other. Okay, so for that to be the case, we can come to, I'm going to close here and close here. I'll come to this index page here. So in this index page, we worked with it in a different way before, but now let's work with it slightly different from how it was. First of all, instead of setting this in this place, this mint history, I'm going to put it in the store itself. So it's not going to be on this React component, but it's going to be on the store. I'm going to be reading it from there. So I will come here, comment at this line of code. I will need two information. Okay, one is going to be a dispatch information, and the other is going to be the function that will be responsible for dispatching that information. So I will come here and say, const dispatch is equal to use dispatch from React Redux. Okay, so I'm going to need that one. I'm also going to need, I want to import global action. So I'm going to say const, I want to get this from global action. Please, it's very important that you note that this global action is not the one coming from this place, but the one coming from this global action, the one that is coming from the slice. You want to import that one. So inside the slice, what we want to get is set sales history. So now, instead of storing this in this use state, we're going to store it here, using this set sales history. But also you want to dispatch this because this needed to be dispatched. Great, so now it is dispatched, and this mint history, we don't want this anymore, but we want to grab it from the store itself. So I'm going to say const, I will say, we need something called use selector, and this use selector, we're going to get the state, and it's going to be of this root state. Is a type that we defined earlier on. This type here, root state, gives us access to all the information here. So now this root state is going to be a function. I'm going to say state dot global state. Now I can have access to that sales history here. Okay, with this sales history, I can pass it in here in this mint history. Sort of passing mint history is going to be sales history. And with this, I don't need here anymore. And I don't even need to put this directly here. So I could save that, and it may not show up first until we refresh. Okay, let's refresh and see how that goes. You can see that everything looks the same, right? And if I open my Redux toolkit at the left side, you see that this contains two histories. You can see these are information on the Redux, so this thing is being captured on Redux now, which is really cool, right? So that's cool. Now let's also do the same for this token balance. All right, so let's come there. I don't know why that token balance is not reflecting properly, but that is how I wrote it, and it's supposed to be so. So I'm also going to get this balance as well. Instead of getting the balance here, I'm going to, and instead of setting this balance this way, we want to consult this, our function in this global actions. It's called set balance. All right, so we're going to grab that set balance there. So we don't need this anymore. Okay, and at this point, you see, one of the things you want to do is, I think I may have missed out this part. Oh, I see why it's not working out very consistent is I'm going to show you why. So let's dispatch this first. So I'll say dispatch this balance. Okay. So with that, the balance should be showing up. You see the balance is showing up, but when I refresh, it may not show up again. You see that? So to solve this problem, what I am going to do is I will come here. I need to put this dispatch as part of the dependency, and also put this set balance, and also lastly I want to put this public key, because if the public key changes, which is this, I also want this to be refreshed so that it can get the accurate information. So if I do this, save that, and come back, you see this thing is showing up. So when I refresh again, you see that it's always there now, which is cool, fantastic, and that is exactly what we want. Okay, we're still good. Now let us do something more. So we're through with this place. Now I need to go back to this buy token. Okay, whenever I'm done buying a token, I want to update my balance with that token, the amount of the token that I just bought, and I also want to update the sales record as well. So I'm going to close here, and I will also close here. I don't need to access this information. So I want to copy this sales history. Okay, I want to copy this sales history. I want to say that, you see that I'm going to fetch that record again. So one of the things I want to do is, one of the problems that you should take note here is, to get the history, we are actually looking at the token mint address. Okay, what I want to do is, I don't want to use the token mint address. I want to use the owner's address, because the owner is the one that is making all this transfer. And as you can see, it's only 2 records that is showing here. It's refusing to show more record, even though I buy more tokens. You can see that I have 5 here, but it's only 2 that is showing up here, because that is not the accurate place to have access to information that is regarding transactions that are happening in this owner's sales. So what we can do to resolve that is let's come back to this buy token. How did we work on this buy token? So we did this. So I'm going to come here and do this as well. Okay, and we also did this. I get the owner this way. Okay, also import this keep here. All right, so now this owner, this is the person I'm passing this mint address. Okay, so I'm passing this owner.public key. So this should be the right thing. So when I save that, you can see that the accurate number of transactions is being displayed for me. That is cool. This is what I wanted. So now when I come here, I need to just copy this line of code, come to this buy token, and after I have confirmed that transaction has been completed, I will do this. I need to fetch this function, call on this function. All this information are available. I need to also do this, get this information here, these 2, dispatch and this function. I'll come here. No, not there. Exactly. Can do that above. Okay, I want to use dispatch and also import this. So at this point, see, everything is all good. So I'm also going to do for the balance as well. I want to update the balance. and we both know that before you even call this function, you already have, a public key, so you can't get away from that one. So I don't need that if-else condition. So I've imported this, so it will get the balance and to get that for me. So those two information are very vital. So now let's purchase one token. Let's say we purchase about 5 tokens more. Let's buy. Unlock. Okay, so let me buy for 5 tokens. Click confirm, and process is ongoing. This is really cool in the sense that it's giving me all this information. You can see that it's been confirmed, and you see that transaction has been updated, and you can see information updated here. You can see the transaction happening. This is very good. Very good. So let me change my wallet address. I want to use dev2. I'm also connected to dev2. You can see it grabs the information about dev2, and you see that dev2 doesn't have any data. So I purchased 7 tokens from dev2 and confirm. You see, it's going to create an associate token account for this guy, which is this. So because that account doesn't have, oh my God, I'm kind of blocking the view, so I'm going to bring it over here. So let's bring it into context. So this account, I want to buy 7 tokens of TCK from this account here, and it's going to create an associate account for this as well. So I'm going to confirm this. Okay, and I'm waiting. Once that has been confirmed, it's going to update everything. Wow, this has been purchased. See, very good. Like, I could then use this to track. So let me close this. If I paste this here, this is where it is stored. The transaction took place online. You can see I have that 7 token. It's exactly the same number of tokens that I have here as well. Like, currently, right now, this whole thing is set, Yeah, that is it. And you can see how many, this is our token supply, all the information that you need to know about this token, version 2 of it, is already here. This is absolutely amazing, clean and sweet. So I'm going to disconnect from this to make sure that everything works even without, let's see if there is any problem. Some of the time, one thing you should know is that the network could be slow, so, you just need to give it a couple of more refresh. Okay, you can see, I think this should be my internet connection. So let me refresh this and see if my internet connection is back. Okay, my internet connection is back. Let's refresh this place as well. You can see that. So it's working without me even connecting my wallet, which is absolutely fantastic. So there you have it. This is how you build a Dapp using the SPL library in Solana. This is just one example of it. And I hope you've learned so much from this tutorial. And if you do, I need you to smash that like and subscribe button and hit the notification bell, because we plan on bringing new and fresh content. But how do we feel motivated is by what you're doing, the feedback that we're getting from you. Please drop your comment and any question you have in our Discord section. The comment, you can drop it in this comment section. Just show some love, you understand? So this is it. And I think one more thing that I could do, what you can do is to just deploy this online, like the one I've already deployed online here, which is this Solana. You can do that using the same method. I've already done this multiple times on this channel, so you can check out any one of our video and make some deployments there. So with that said, much respect here. It's Darlington Gospel, and this is Dapp Mentors. I will see you in the next videos. Bye bye.